Start on time. Banquet that we just had. We are going to have this afternoon of our conference, and we are going to have Nico. Let me just have my tell you the Nicolas Trachter talking about sectoral development multipliers.
Okay, yeah, now you can hear me. So this is John work with Paco, and it's part of our agenda of understanding development and macro, putting them together. And we're part of this new push towards understanding how to develop the economy, okay, through big push and similar ideas. Okay, so economic development, in my mind, the idea kind of hinges on the adoption of modern complementary technologies, okay? And we all know in this kind of literature that distortions hinder this process, and the result is underdevelopment, okay? Now, as a result, industrial policies, there's a long debate, famous thinkers pushing for the notion that there's a role for the government, okay, to alleviate these distortions with some policies to promote economic development through adoption of modern technologies, okay? At the core of this notion of development is this idea that firms are connected, okay, through an input-output network or whatever. Okay, and there has been some developments lately in multi-sector economies with IO networks, okay, and there's some famous paper by Baki and Fari, Saki and Chen-Chen's papers, and then there's another important paper by Ernest Liu. Okay, and the open questions, at least in my mind, are kind of two. Okay, there are more. These are the two questions I will try to answer is how to think about industrial policy in order to promote economic development, meaning the adoption of modern technologies. And two, given that, which sectors and which policy instruments are those that we should think about as crucial for this development, okay? So that's going to be my goal today. So our paper is a quantitative study of technology adoption in a multi-sector economy with complementarities, okay? And it builds in this other work that we have with Hugh and Youngs. Okay, and the key ingredients is going to be a very, very simple model. And the key ingredients are three. One is technology adoption, so firms have to choose between adopting and not adopting and something modern. Second important ingredient is going to be distortions. And the third important ingredient is going to be a rich IO structure across sectors in the economy. I will use the size distribution of firms or establishments to try to make sense of technology in each sector. And we will build all of this to have a laboratory to ask the question I was telling you about before, that is, which sectors and which policy instruments are the right ones to promote economic development, okay? In order to do this, my approach is going to be, as in the literature, I will do a local analysis, kind of, given an equilibrium, I was going to study a small perturbation to the equilibrium and see what's the best way to achieve development. Okay, so everything's going to be kind of local analysis, first order. Okay. So let me just keep the literature. So the plan for today, I never make it. So, but let's say the plan, if I were to do it correctly, is first I will go through the theory and describe what it is, the theory, what are different roles of stuff. Then I will show you I will tell you how we parameterize the model. I will skip that part altogether. Then I will show you revenue multipliers across sectors. And then we study what's the best instrument for achieving promotion of technology adoption. So first of all, let me say I'm a macroeconomist that works mostly in static models. Okay, so given that, this is going to be also a static model. Okay, and it's going to be very simple. So the economy is going to be populated by, say, people/workers and establishments. So these people, I will aggregate consumption using a CS aggregator. Okay, this C, where gamma S is the share or the elasticity of operating consumption to a particular output produced by a particular sector. Okay, so they're going to be S sectors. So I will do everything with matrices, okay, eventually. So every time you see something in bold, that's going to either a matrix or a vector. So the matrix, the vector gamma collects all these small gamma S's. Okay? Now, within each sector, establishments compete with monopolistic competition, where eta is the elasticity substitution across varieties within the sector. If you notice, eta is not varying with sector, so every sector shares the same eta. Okay? Now, the third one says that firms or establishments are going to be different in two different ways. One is that before they enter the economy, they will draw productivity from a Pareto distribution, where zeta is the tail parameter. Okay? So if you remember the Pareto distribution, high zeta makes the distribution more like kind of more spiky. So firms, establishments are more similar to each other. Lower zeta, more dispersion. And this ex post part, just forget about it, okay, for today. Now, establishments will produce using labor, but also intermediate inputs. Now, these intermediate inputs come from the same sector and other sectors, and that's regulated by the matrix of input-output in production, omega. Okay, so in sector S, you also use inputs from other sectors, S prime. Okay? When you produce, you will produce with a Douglas production function, and it can either be traditional or modern. I'm going to make it very, very simple. So the only difference between traditional and modern is going to be just the productivity parameter. Okay? Now, if you want to be traditional, okay, this is going to be a productivity AT. And in order to be traditional, you have to enter the economy, and the cost of entering the economy is going to be measured in labor. Okay, and each sector has a different cost, kappa TS. So T is traditional, S is the sector. Okay, different sectors may have different entry costs. If you want to be modern, you have to do, first, you have to enter the economy, so you have to pay this cost, and you also have to pay an extra cost to be modern. If you're modern, now the AT becomes AM, and you have to pay another cost, kappa TS, sorry, kappa TM, this should be kappa TM times the price of goods. Because we're thinking that to build a modern firm, you need technology, and technology is capital embodied. Okay? So there's going to be an input-output structure for production, an input-output structure for the adoption good. Adoption good has a different input-output matrix, lambda. Okay, so there are two different ones. And that's basically the economy. I'm done. So the problem of an establishment is very, very simple. Okay.
Nico, just to focus, so across sectors, what is the difference, the main difference across sectors?
The only difference across sectors are you're going to be a different row in this matrix omega with different ingredients here. You will leave a different row, but you don't see here in the matrix lambda. Mm-hmm. And then in principle, you may have different costs of traditional and modern.
Thank you.
Okay. No, the TSP is common. It's just AT and AM. It doesn't vary with sector. Just to keep it very simple. So pick an establishment that's already active in the economy. Okay. So the profits of the establishments depend on its productivity that it drew, okay? And it has to choose a price. Given the CS structure, this is the quantity, okay? This is the price index facing in that sector. You have to pay for intermediate inputs, for labor, okay? And then all these things, I mean, it's hard from, do you see well these things from here? I don't see them very well. So these things here are subsidies, okay? In principle, the planner can decide to subsidize the economy in different ways. It could do a revenue subsidy, it could do an intermediate input subsidy, it could do a labor subsidy, or it could also do an adoption subsidy, okay? That is kind of here, okay? So that's the problem of the firm. It's very simple. Given it has a production function that has to cover for the total quantity to be produced. Now, because this economy is very simple and these Pareto shocks are drawn from a continuous distribution, the solution to the problem is going to be trivial. There's going to be two thresholds. One threshold in a sector that will regulate who enters, who doesn't enter, and it's traditional. So at this value, you are indifferent between entering and not entering in traditional and paying the entry cost. And there's got another threshold that will regulate that among those that enter become modern, given that you also pay the adoption cost. Okay, that's the solution to the problem. So it's very, very simple. So for each sector, two thresholds. How many sectors? Two thresholds for each sector. You solve for it, you're done. Okay? Now, given a threshold, given a Pareto distribution, every establishment above that threshold is the mass of adopter or the mass of entrants. Okay, so instead of talking about thresholds, I'm going to be talking about mass of adopters and mass of entrants. Okay, so every time you see an A, that's the mass of entrants. Every time you see an E in sector S, that's the mass of entrants in that sector. Sorry. Okay, let me skip this because we talk about it. So before going to the kind of the things that are more difficult, let me give you some aggregates and you'll see the logic of the argument of big push and promoting development with complementarities. So you could think that this economy is an aggregate production function. There's also Cobb-Douglas. We aggregate all the labor used by firms, you aggregate all the intermediate inputs, and as a result, you have residual that you can call TSP. Okay, and you go and measure this TSP. That basically TSP is just for all firms that are active. Okay, you count how many are traditional. Okay, given the distribution, these guys are active using an AT, and then you count how many are modern, their productivity, and these guys are active using AM. Okay, this is just aggregate productivity. Okay. You can also go and compute prices. This sector prices. Remember now, this is a bold P. It's a vector. Okay, so each entry is the aggregate price index in each sector S. Okay, and this connects prices with aggregate productivity in each sector and all the different subsidies in the economy. Okay. Now remember that this TSP term is endogenous, right? Because through entry and through adoption, there's changes in who's become modern, who's traditional, and that's affecting aggregate productivity. And aggregate productivity is affecting prices. Because prices are an input in production, that is important for other firms to produce. So that's already kind of the source of complementarities. So again, let me tell you more about it. Finally, so if this adoption, okay, if I increase adoption here, this is going to be a pass-through to total productivity. That depends on the distribution function I'm using and parameters like that. So this D log Z, D log A is the elasticity of sectoral productivity to a change in adoption. Okay, that's regulated by the parameters of the economy. Okay, before moving forward. So imagine for a second that there's more adoption. Just exogenously, I tell you there's more adoption. What will happen in some sector? Because there's more adoption, there's going to aggregate productivity in that sector will go up. Okay? Because productivity is going up, then the price index in every sector is going down. Because the price index in every sector is going down, the marginal cost of production is going down everywhere. So firms are producing more. And because technology is complementary to production, you want to adopt modern technology. Further, the same challenge implies that the price index of the adoption good also goes down, and this reinforces the idea that you want to modernize your production capabilities. So when some sector adopts, this goes through the input-output structures, motivating other firms in the economy to adopt because the marginal cost is going down and because prices are going down. Okay, motivates you to adopt.
Nico, adopt is to change the limit of the integral.
Yeah, kind of something here is kind of changing a little bit this number here and this number here.
Which is the same number, or not?
Right, this define
Okay.
who's the marginal guy. The marginal guy is traditional or modern. Okay? So I will show you now more math, but this is how it kind of works. Yeah.
And Nico, the fact that the entry is paid in labor and not in goods means that there's also, you don't have interest at the bottom when you have more adoption all of a sudden, no?
So let me put it differently. So the fact that entries in goods, in labor, it just makes it that I cannot kill in some sense the complementarities in entry. If I were to also do it in goods, I will reinforce action. I just in my head, I'm thinking that building a modern firm kind of requires technology, modern technology, while I'm less clear about it for entry in the economy, in particular for India, let's say. Okay, but it's kind of important for some things we'll kind of skip today, but we can talk later. Okay, so I didn't tell anything about multipliers. Let me define a multiplier. Let me show you some theory, and we keep going. Yeah.
And just a short question. So
Yeah.
I guess you usually think that there might be some increase in the wages, right? When you have a high demand because of a higher Z, that could sort of make it more of a substitute as opposed to a complement. But I guess here that's playing or that's not playing.
So here's not playing, first
Yeah.
because actually so labor supply is kind of fixed.
Okay, I see.
But that can be there in different ways. But it's not necessarily the case that we go against, but there's reasonable models I can build where it will go against.
Okay.
So let me define a multiplier. Okay, and we'll do this thinking about revenue multiplier. So revenue subsidy, all the other subsidies will have similar objects. So I will call the revenue multiplier in sector S just this, that this object is the elasticity of aggregate consumption to the subsidy around the equilibrium with no subsidies divided by the total cost of the policy. Okay, so what does this mean? It means that if this number is above 1, it means that you put $1 and aggregate consumption goes up by more than $1, so success. If the number is below 0, you put $1 and you get negative, so that's terrible. Okay, and if the number is between 0 and 1, you put $1 and you get less than $1, so not a great idea. Okay, so the idea is going to be at the end to go and study which sectors are the best. Again, you have some amount of resources, where to put these resources. Okay? Now, I told you there were distortions. Which distortions? So in this paper, the only distortion is the markup distortion. So my distortion today is just markups. Okay? So given that, all subsidies we try to play in such a way to try to correct the market distortion. If we correct the market distortion totally, there's nothing to do. It's all efficient and we move on with our lives. Okay? Now, there's two channels by which the subsidy will play out, the revenue subsidy. The first channel is production. Okay? If I subsidize a little bit revenues, that will affect demands for labor and intermediate inputs, and this will affect eventually aggregate consumption. This is kind of the Bakian-Fari paper. This first row is Bakian-Fari, a famous paper. The second channel is our channel, what we call the adoption channel. And how it works? You subsidize things that changes incentives for adoption. Adoption changes, that changes aggregate TFP, and aggregate TFP is converted to changes in aggregate consumption. Okay? So my plan now is going to be talk about this row and the last row of the second part, and 3, and then backward induction towards a full picture.
So a basic question, why not a sales tax will undo the markups and then you're done?
You can, yeah. So I'm saying if the rules of the game are here are not to kind of physical distortion. So if you were to put the revenue subsidy to be equal to the markup, you're done. Everything's efficient, and we move on with our lives. They can more thinking that this can be a big number, and you also may need to know a lot about the different sectors. Given distortions, where I should put like a little bit of a subsidy to promote development.
But you are not allowed to for revenue subsidies, or?
So I'm going to talk a lot about revenue subsidies now. But yes, so if I were to choose the revenue subsidy to be equal to the markup, you're done. Okay? Okay. So don't be scared. Okay? I mean, like, you know. So again, so I'm going to be talking about this elasticity of consumption to respect to the subsidy. So you do some work, okay? You can write the elasticity of consumption with respect to to these things as the following, as two terms. So here I have d log r. Okay, so it says, you change, this is a production channel, this is Bakian Fari. If you were to change a little bit with the subsidy, aggregate consumption will go up as a function of a difference of these two matrices. Now we talk about them. Now, there's another channel that is through the TSP channel. I told you that when you do subsidies, that will change adoption will change TSP, and given a change in TSP, that will be converted through adoption into consumption through this difference. So if this entry is positive, good. If it's negative, bad. If it's zero, irrelevant. Okay? Let me tell you quickly about the Bakian Fari term, and once you understand that one, the other part is going to be easy. So what is the Bakian Fari part? It has these two objects. This one, David and Emmanuel call it the cost-based dollar weight. We call it the forward dollar weight. Okay, let me tell you what it is. First of all, this is a formula. It's kind of ugly, whatever. And it has a few things. So imagine that I subsidize a sector. Okay, so that sector will grow. There's higher demand for this sector. Okay? How much higher demand? Well, the higher demand will be proportional to final demand elasticities. The final demand elasticities has two terms. One term is the elasticity for consumption, the gammas, and the second term is just some adoption costs, and those accumulate to become final demand elasticities. That's the first round effects. The second round effects is that because I'm producing more, everybody's producing more. Okay, I'm passing forward the subsidy that I go to everybody that's connected to me. Okay? So the first round is going to be, and everything is proportional to how we're connected through the input-output structure. So nu is the independent input share, and omega tells me how sectors are connected. So the first round of the connection is just nu times omega. The second round is d squared, and so on. Okay? If you keep going with this, you get the famous Leontief inverse. Okay? So that's that. Okay, how you pass forward this subsidy. Okay, and this is this object here. Now this one is called the dollar weight, or we call it the backward dollar weight. So what is that? It's kind of, okay, it's fine. We are producing more, that's great. But for me to produce more, we have to reallocate labor towards me, and all that sectors are producing more because of this subsidy. And this labor was used somewhere else. Okay, so this dollar weight accounts for all of that. Okay? One difference is that this one appears also the inverse markup, while in the forward dollar weight it doesn't appear. Okay? Because of distortion, going back to what Julian is saying, because of distortions, okay, labor or gross output is not the same as final demand elasticities. So that wedge is what gives a role for the government to play and try to promote the development. Okay? So this is just Bakian Fari. Okay, so look at this other term. It looks very similar. It's the same term, basically, but with the kind of inverse markup there. But it's not the inverse markup. It's related, okay? So think about it, okay? So what I need to do, I need to motivate these firms. I want firms to adopt, okay? And then convert that to TSP, okay? So in order to convince firms to adopt, I have to give them profits, okay? Now, profits for a marginal firm are proportional to 1 over nu, 1 over eta. So this eta appears here because that's the rate at which the marginal firm profits go up with the subsidy. Okay? So lower era is kind of great for this, okay, for the economy, because it's all about surplus, it's not about output for the firm. Now, era -1 is the fact that era -1 regulates the elasticity of how I convert adoption to TSP. Okay, so if it's very cheap to convert, then I get a lot of output. Okay, so it's just the same as before, adjusted for the cost of motivating firms to adopt times the conversion rate of adoption to TSP. Okay, so that's that.
So Nico, it's all because of the monopolistic competition distortion, and there are no externalities.
That's externality. It's that kind of because I'm distorted, I'm passing through my distortion through the input output to everybody else, and everybody is distorted because I'm distorted. And through the I/O structure, all of this is compounded many, many times to give you the inverses. There can be big numbers. Okay?
So the externality, so the marginal guy is making a decision of whether to be in the M or the T sector. Can you explain the decision there and the externalities that the R would undo?
That guy is not understanding that at the margin he's affecting kind of prices in such a way that demands for all the other firms and the adoption costs of all the other firms are affected by it, basically. Okay?
So if you want to design a Pigouvian R, is it going to be the
markup.
eta over eta -1
Yeah.
or
The markup, and that corrects everything.
okay?
Okay, I should go fast because, of course, I'm very far away from ending. So this was the problem given. Here I didn't tell you how, this is told you, given at Z, how consumption happens. I didn't tell you how the subsidy affects adoption and how adoption converts it to Z. So okay, now let me go back one step, understand that the margin. So if I grab the margin adopters condition that Andy was referring to, you had this baby, whatever, and in here you get, it's kind of a cute object. I know it's ugly, but I like it. This tells you the elasticity of adoption. Okay, in a sector, these are vectors to changes in adoption subsidies. Okay, and it's kind of nasty. Okay, but let me tell you what is kind of beautiful, and then we will keep going quickly. What is beautiful, I think, is that you look at it, you see these two inverses. So an inverse here, and there's another inverse there. Okay, this inverse here is what everybody gets in their papers. It's called the Leontief inverse. Okay, so the whole game in paper is to get out of amplification, you need to make this object kind of very close to zero, because then you invert it and it explodes, and then you get a lot of amplification. So the whole game there is how to make nu either to be very big or something about the omega special. Here you have these two inverses, okay? So in some sense, it's kind of nerdy, but I like it. I don't need to worry that much. I'm making things very extreme here because I have this other function that helps me keep magnifying things without the need to go to extremes. Okay, so this is pretty unique of these kind of settings, of our setting. But I will keep going. So if I put all together, I put all the machinery together, I will get the elasticity of consumption to respect to revenue subsidies. Okay, I also put the adoption subsidy here because it's kind of an important one, but forget about this row. So the first row is Bakian-Fari. Okay, this is a part of Ernest Liu's paper. The second row is our guy. Okay, so let me give you one insight. Okay, this is a famous paper by Acemoglu and company, Vasco, Carvalho, and others. That if you think about things exogenous, think of TSP as exogenous, not endogenous in our paper. This object here, this is what the forward over weight is what they call influence. So influence is, imagine you were to hit TSP in sector S, influence will give you the effect in aggregate consumption, aggregate output. Okay? So in some sense, this object here, okay, sorry, this guy times this object here is influencing adoption. If you were to shock the technology of production of adoption good, okay? This will tell you the pass through to aggregate consumption. And this is Pacos and Nikos, okay? Now, I told you that the multiplier was the ratio of this elasticity to the fiscal cost of the policy. Okay, so Ernest Liu in his paper shows these things. So the fiscal cost is just a very simple object if you solve for it. For example, if you do a revenue subsidy, the fiscal cost is just the dollar weight. So you go and divide this object by the dollar weight, and that's the multiplier. Okay? Okay. Kind of fine. Let me tell you quickly about what would be the roadmap for estimation. Okay, then I keep going to results. So first of all, I didn't tell you which country I'm talking about, okay? So I will think about India. In particular, we used the 2013 year as my relevant year for India. So we had the census data. Okay, we had 32-digit sectors. Okay? Now for each sector, I have kind of the size distribution of establishments. And my goal is going to be, I want to go and back out for each sector. I want to look at the sectors and come out with estimates for adoption and traditional and modern parameters and so on and so forth. Now, calibration of these models are very difficult because they're all interconnected. 10 and 30 seconds. Because they're all interconnected. When you change one parameter, you need to understand how that affects actions in all other sectors. Okay, so solving for this in a computer is kind of very challenging. Okay, so it's hard to understand where you want to go and search for parameters. So we have some sort of solution to this. Okay, so we can actually show that you can actually solve this problem in different pieces. You can go sector by sector and back out things, and then use the whole equilibrium construct to make things of everything together. There's some sort of block separation of the problem. Okay, so basically for each sector, you can go and write the size of an establishment. This is the employment of an establishment as in log as something additive. Okay, that has the technology choice. This could be T or M that the plant is using, modified by some, this tilde, there's some other objects multiplying that. Then the productivity, the Pareto thing that it got, okay, plus epsilon. This epsilon is what I didn't tell you at the beginning, some other shock that I have there. Okay, so I can use this structure and estimate this for each sector, back out everything, and then I use the equilibrium and back out the kappas later on that makes sense of everything together. Okay, and we have some unique proofs somewhere. Okay, so I cannot hit. Is it possible to click? I don't see anything. On examples, can you click on examples back there? Here doesn't work. If you can't, you can't. ¿Se pueden apretar el botón de ejemplos? ¿Este? No, el de ejemplos. That was a bad idea. I realized that. Press back. Okay, I do it. Yo lo hago. Okay, I want to show you this example so you see. So again, I'm making this very Mickey Mouse. So I'm only allowing sectors have the same technologies. The other thing that's allowed to vary across sectors is just the kappas, as telling you before, and that's kind of it. Okay, everything else I'm assuming to be common across sectors. So I'm really tying my hands in a crazy way. So these are four examples, and I'm estimating everything together. So let me show you 4 examples. Let me start with this one. With wood. This is the manufacturing of wood products. This number here is my estimated amount of adoption in the equilibrium. So almost nobody is adopting in this sector. Now, I cannot, blue is data, red is model implied. If you look at blue, forget about red for a second, this looks pretty Pareto. This is a Pareto. So the model is going to say, there's no adoption. Okay, move on, man. So this is how the estimation interprets this. Okay? On the flip side, go and look at mining. Blue again, okay? Forget about red. You look at mining, you see these two, the shape is kind of bimodal. There's two modes, okay? Because there's two modes, the estimation will think the only way you can have two modes in this economy is by having a bunch of adoption. So the adoption will separate firms, and each of them will have its own mode. Okay, so they say this adoption, and that's why kind of how red kind of mix the data. Okay, and whatever. The other two examples are what they are. I have to go back. Okay. Then just to finish the part of calibration and estimation, that was all the reduced form part. Then to make sense of everything all together, I had to keep picking parameters. So for omega, for the input-output of production, we use the word input, the word IO database. Okay, so you have this data for India, and then for lambda, we use the Baum-Lennan-Winberry similar object for the US. Okay, for the adoption good. Okay. Then following Brown, Weinstein, and Xiang-Clino, we assume eta equal to 3. And to match the independent input share in India, we set nu to be 3/4. Okay? And finally, I prefer that you to color the nice face. And finally, yeah, this was telling before. Finally, use the whole model to back out the kappas. That's the object that I really care about. And the kappas are uniquely determined. Okay? They're uniquely identified. Okay? Given that, I move on. Now let me show you the last 5 minutes multipliers. I cannot believe I'm going to finish. It's amazing. Okay, let me just start with the general ones. Okay? So what is this plot? You cannot see anything, but each of these is one of the different 30 sectors. Okay? Now, each cross is my estimate of the sectoral revenue multiplier. Each kind of line, I do kind of a bootstrap re-estimation thing to see how good are my estimates. Okay, you see some variation, okay, but what you already see here is that rankings and real values will not change that much. Okay? Now remember also, what is demanded is numbers above 1 are good, a 6 is kind of great, right? So if I'm going to now and tell you which sector I want to go and do stuff, they will tell you, okay, the best sector to go and put money on is basic metals. Okay, the second sector is going to be machinery and equipment. Third sector is going to be mining, and so on. Okay. Now, why this saying in basic metals it was a high multiplier? Why is that? I told you that the multiplier was the ratio of the elasticity to the cost. So here I'm plotting in the x-axis, I'm plotting the multiplier. And the y-axis, I'm plotting the elasticity. And here I'm plotting on the x-axis the multiplier, and the y-axis the cost, the dollar weight. So look at this. So basic metals, I told you it's the key sector, doesn't have the highest elasticity. In some sense, it's kind of intermediate values of elasticity. But what happens is that basic metals has a very low cost. It's kind of a small sector. So it's pretty well connected, important for complementarities, but it's kind of cheap to do policy there. Some other sectors have very high elasticities, like trade. Trade is very central, very important, but trade is also a very big sector. So doing stuff in the trade sector is very expensive. Okay, so the most efficient way to promote development is not to go to the most central, it's to go to the most, in some sense, adjusted central. Okay? So what is this plot? In the x-axis, I'm plotting the ranking, the implied ranking I will get in an economy with no adoption. Okay, so it's just the Bakian-Fari economy or NSU economy. And in the y-axis, I'm doing the same, but for our economy. The ranking of the different sectors in our economy. Meaning, this sector here, sector 19, ranks 10 in my economy. With adoption, ranks, I don't know, 2 or 3 in Bakian-Fari. Okay? So what you see here is that you will see, I will go quickly, you will see a lot of ranking reversals. So if you're going to infer the importance of a sector in an economy with no adoption, you will find the wrong results because some sectors are going to be interpreted as very important when actually they're not very important. Okay? Now, I told you there's some reversals. So in some sense, there's something in the economy with adoption that is different with the economy with no adoption. Okay, so amplification through adoption is kind of crucial. So again, here I have each sector. Now the blue object is the multiplier with no adoption. The red object is my multiplier. The difference is amplification through adoption. Is that guy there? There's the same letter that Matthias was using, but it's kind of nastier, or at least to me. Okay.
So, Nico, can I, quick question. In general, in these economies, you want to tax, and here you are subsidies. So you are doing subsidy. So you're
why are you saying that you want to tax?
because there's a markup. So usually, we want to tax away the markup, and you're doing a subsidy. So this is coming because you are looking at this multiplier and not doing the planner solution to go back to the constraint efficient
I told
allocation.
you that the revenue subsidy. If you want to clear the markup distortion, you would choose RS equal to the markup. So it's also a tax, a subsidy. You don't want to tax away. You want to kind of correct the effect through that. You want to clean up this effect. The way the subsidy appears is because you're in labor demand and in demand for immediate inputs. What will appear is the inverse of the subsidy. Okay, so you have to in that way you correct for the market.
But you can also do it with the tax.
Eh?
You can also do it with the tax.
I mean, it's the same thing. I don't understand. I mean, like,
But the fiscal implications are very different if you do a tax than a subsidy.
You have to choose RS equal to the markup. If you choose the opposite, you cannot do it.
No, but
Okay.
there is another thing here that is because you have this positive fiscal in all the places where the multiplier is bigger than 1, let's say that you have this policy that is, I tax consumption for everybody, I use all that revenue to subsidize the ones where the multiplier is smaller than 1, the other ones I tax, and you can always have a budget surplus if you do that. So you just do them all, right? You don't have to pick.
So that problem is pretty difficult. So do that problem, I'm saying, I don't want to do the game of solving the whole distortion. To solve the whole distortion problem, you set the subsidy equal to the markup and you're done. There's nothing else to do. At the local level, you want to play this game of which sectors
No,
which sectors
I understand, but you're doing that because you're saying that you have limited resources, but because the multiplier is so big, if you tax consumption, it's easy to tax consumption.
Yeah. Then
you give all the subsidies. The complicated subsidies is what you're doing, but you can finance.
I'm just telling you, it was choose a subsidy equal to the markup, you solve everything. I don't understand in which sense that's hard. That's very easy.
No, because I understand what you're saying is I have limited resources for the subsidies.
No, but I didn't do that. I didn't put a restriction. I'm telling you, this is the logic of the argument. Yeah.
No, but the reason why you want to look at the multiplier is to see where you're going to put the money,
This
right?
direction is because the logic is, I want to provide you direction on how to do policy.
I understand,
Then you
but
decide your political
why do you need the
constraint.
direction if you couldn't do if you don't have a budget constraint to do everything?
I'm just saying that it's hard to solve. I mean, like, I know. So let me conclude. I want to conclude with just one observation that if you want to ask which subsidy is the best way, what's the best policy to solve the, among all different instruments, which one is the best instrument is to do adoption subsidies. Okay, why? It's mostly because there are cheaper ways to promote development. So just to conclude, yeah, so we just built this lab to study industrial policy in a multi-sector economy. And I think we provide these novel insights about amplification policy through adoption. We estimate this model, I didn't show you much because we don't have time. And our results kind of suggest some important things, that is big amplification through adoption. Technology adoption is crucial to understand which sectors are important. And the best way to do things is through adoption subsidies. Again, a natural extension I want to work on is the same idea, but to study the adoption of clean technologies. Okay, where clean sectors also want to demand things from clean sectors. So it seems like a natural next step for us. Cool, thank you.
Thank you, Nico. The discussant, Jorge Pinto Miranda.
Hello. Thank you so much for inviting me to discuss this paper. Before we get the slides here, so when I was a PhD student at UVA, I used to go to Richmond, and Nick always had really, really good questions. And I think you're answering some of that questions here in this paper, but in my discussion, I'll try to push a little bit more. So these are my views. These are not the views of the IMF. Okay, so the idea of this paper is to ask the question, can we promote economic development by supporting these key industries, right? And which policies are the most effective? Existing work highlights that studies production networks, linkages, and development is very limited in the sense that we assume, I'd say we because one of those papers we recently published, we assume exogenous productivity, we assume exogenous network, although we play a little bit more with distortions, we introduce financial frictions, which maybe alleviates the previous discussion, right? In that sense, pecuniary externalities come from the fact that one sector decisions do not internalize how they tight the borrowing constraint of another sector that is connected, so policies tend to correct that. So, but this is something that you can easily add. It also applies. And this paper contributes to the literature in adding adoption in production networks and highlighting how there is a tight and strong interaction between them. I think that's quite nice. And it provides an analysis of effectiveness of different policy instruments. Ernest Liu has a great paper on that. One of my chapters, my dissertation also analyzed different policy instruments with financial frictions and production networks. Oh, so these are the key equilibrium objects in the model. We have the Domar weights here and the cost Domar weights, which as you can see depend on the consumption shares, adoption, the investment network, the input, the Leontief inverse. And here sectoral distortions over here can be, sectoral distortions are market power here, but they could also represent financial frictions, as I said, or any other type of friction, as in visual law or a recent paper that I also have with Eric Young. And this is the main element here, and this is the nice thing of the paper, and I agree with Nico, this is beautiful, because as you can see in the elasticity of aggregate consumption to revenue or any subsidy indeed, typical papers that we analyze with Ernest and others, and Bakai and Fari, of course, you have just this first term, right? But then by adding this very simple way of adopting a new technology, you have all these additional terms that add a lot of action and a lot of traction. So to answer one of your questions when I was on the market, how small changes in the network can actually have important aggregate kicks, and this is one way. So, but comment one. So adoption changes the production structure, right? So this relates to your future idea of going to clean technologies. So in transportation, for example, if you want to think about electric buses versus diesel buses, right? You're going to have to invest in that. You're going to buy the clean bus. It's going to be expensive, but it's going to increase productivity. Given because you're going to need less people to maintain the same bus, but at the same time you're going to stop using a lot of inputs. You're not going to need any more oil or diesel, no more engine oil, no more distribution belts, engine park, spark plugs, etc. You're going to need new materials. You're going to need charging ports related inputs, batteries, battery recycling material facilities. And to produce electric buses, assuming we're in a closed economy and you need to produce these electric buses, you're going to need a lot of copper, lithium, nickel, etc. Other type of adoptions with artificial intelligence will require new links, new providers in artificial intelligence or software providing sectors. So what I'm trying to say here is that over the development path, right, networks are endogenous, network change, and we really want to think about that because this is crucial. This is from a figure of the paper that we recently published, and this is consistent with Acemoglu and Azar analysis over the development path, log GDP per capita here. production networks become complex, denser, right? When you adopt these new technologies and you improve productivity, you start using more and more different inputs, and the production network is actually much denser. Similar with the investment network here from Kaunedo and Casal in Korea. Korea 1965. This is the investment network, and look at Korea 2014. So the authors don't have this, and that would be super complicated, right? But you do have something that you can do about this, and I think I want to push, that is super important, which is going to come next. Oh, this is also at the firm level, even in the short run, networks are super endogenous, right? This is how, in a project with Luis Felipe Cespe, Alvaro Castillo, and Javier Turen, during COVID, production networks reallocated, reorganized quite a lot, and also the dispersion of firm size and everything changed. So the point I want to make, again, is try to be constructive about this and say, you don't have lambda and omega being endogenous, but the beauty is that given that you have endogeneity within sector adoption, the relevant network for your analysis at the sectoral level, which is, say, this time that, it is changing, right? Because adoption rates are endogenous and they change, this network that is relevant for the analysis changes over time. And I think that could be really cool, that if you can take advantage of this and say, simulate certain policies, and say, can we match the evolution of the production network in Korea, or in India, or in Peru, after certain policies to certain industries were implemented. The second comment, as you might all be thinking, is open economy, right? Developing emerging countries are small open economies that rely on a lot of exports and imports. And because I have not much time, all I want to say is that a big part of the action that you have in your mechanism hinges on this, the fact that prices change. But India export aluminum, but India's policies will not actually affect aluminum prices quite a lot. So in that sense, if you consider a trade, right, the fact that you import and export a lot of commodities, that's going to potentially mitigate and mute a key part of your mechanism. And then what I would like to see is, like, maybe for a future paper, is like how your multiplier would change if you say you simply add the small open economy part of the model to base metals, say, just a simple example. Base metal prices are exogenous, you're not gonna affect that. Potentially that changes the identity of the sector because you really wanna improve or reduce the price of the adoption good that uses a lot of base metal, arguably, but all other sectors as well, a lot of them. So I would rephrase the question, given the network centrality of these tradable sectors and the evolution of international commodity prices, what sector should we target? And should we think of different policy instruments in this small open economy as exchange rate policies, for example? The other is about policy implementation. Implementing and changing policy, these subsidies, these taxes, is quite hard. What is much easier is to target granular government spending. So Australia recently, because of precisely the commodity price changes, the nickel sector in Australia is suffering quite a lot because nickel prices are going to the floor, right? So then what they did is they changed in the budget government spending and investment on that sector that easy. So that's much easier than say we're going to promote subsidies to this particular sector and pick winners. The political economy of that is complicated. So Gassive and Ferrari have a recent paper in which they do that. They look at government spending in a production network in a new Keynesian framework. They don't have adoption though, but it would be nice to add this additional policy instrument. And finally, the trade comment also changes your calibration. We know that Alamelids, right? Forget about adoption, just think about the Z. Trade openness, which is relevant for India, will change the distribution of employment, right? So are you capturing that? Maybe half of your adoption is actually just simply international trade. So you could take advantage of the World Bank adoption of technology survey just as a potential. Then what do you assume about the profits? I assume that profits are thrown out, you're not rebating back that to the household. Yeah, are you rebating the back? Okay, so that's okay. So for future research, elasticity of substitution in the long run are larger, right? So in the long run, you can adapt to these new technologies. So Cobb-Douglas might not be the best from a policy perspective, and also adoption takes time. So currently, you assume instantaneous adoption. There is no depreciation of this adoption capital technology, so that could be future research. So to finalize, super interesting and relevant paper. I am biased because I really like this topic. There is a lot to learn from incorporating this simple adoption. You saw all these additional terms that amplify subsidies and policies. So it's ideal setup that I would love to think about, use to think about a small open economies emerging market like ours. And besides the current contribution, it opens up so many questions for future research. So thank you, Nick.
Thank you, Jorge. A few minutes to react to Discussant and collect some questions in a minute.
Sure, I will react. That's a great discussion, and I appreciate it a lot. I want just 3 generic comments. One, to think of dynamics. I'm going to call it dynamics in general. Of course, this seems to be a natural thing to do. It's very, very complicated because with complementarities, it's very hard to solve these models. But we're kind of thinking with Fernando, Alberto, and these guys to try to do something about it. But Ernest Liu has a new paper that shows that you have all these multiple equilibria. It's kind of makes sense to do it. It's kind of just hard. International trade, I agree 100%, but I would put it the other way. So if you would have a lot of imports and that price is kind of fixed because it's an import price, I cannot play with that price, so that's a problem. But what you can do then, even with exports, is, as we did in Argentina, you put capital control. You can do different things to start playing there. So I don't think that would naturally kill it. It will kill it if I don't do these other things, but the idea will keep, it will maintain. And in terms of implementation, yes, I mean, these things are hard to implement. And in particular, an adoption subsidy seems very hard to implement because you have to know who's going to be adopting. And I totally agree with you that maybe this is not very real as an application, but it's a good exercise to think about which sectors are important, and then we can think what's the best way to promote these sectors. But thank you very much.
Can you collect some questions, Paul?
So your original model includes firm entry. I would have been interested to hear more about the implications of that for your result in the analysis. So for example, you have variety effects potentially working in one direction, selection of firms and the distribution working in another direction. How do you balance the benefits of product versus process innovation in here? I heard a lot of process now. But there's product in there too.
Yeah, just to make it kind of short.
Let's collect Yen.
Yeah.
Very interesting paper. So I have a question about the data. We know that India or lots of emerging markets already have implemented large subsidies or industry policies. But I guess in your quantitative model, you're assuming that there's no subsidy in the data. Do you think that would generate a bias, or would that explain, like in your estimation, that's different from the existing literature? Yeah.
Another question? Go ahead, Nico.
Okay, let me start with that one. It's a great question. I mean, let me just reply short, and we can talk more later. So entry happens to be very secondary here. So the entry margin doesn't play much of a role. Which is great because otherwise you will start worrying about the love for variety effects, all these other kind of things. So it just doesn't play much of a role. However, selection is relevant also through adoption, okay? But we can talk later about it. But the entry margin and the love of variety that I will be afraid of as an important part of the answer is not a crucial aspect of it. Now, what Jan is saying is a great comment, and the way I'm doing this is whatever distortion, you can even think of whatever they did, subsidies or whatever, in some sense, it already affected allocations in either as a distortion or not. It is what it is. So all of that in my planet is distortions. And the economy I see is distorted, and of course I'm interpreting this as a unique distortion is just the market distortion, but you could think about adding others that would be more natural, but then you have to start making a call of which is touching this sector, that sector, and so on. So we are agnostic, not because we love it, mostly because we don't know exactly how to deal with them across sectors. But well taken, your comment.
Okay, great, thank you. So we'll reconvene at 3:15. Restart.
Okay. But it stays on.
Okay, excellent. So next we have Francesco Ferrante, and he'll talk about devaluations, deposit dollarization, and household heterogeneity.
Perfect. Thank you very much. First of all, thanks to the organizers for including our paper in this fantastic conference. I'm going to present joint work with my colleague Nils Gornemann at the Fed, and the usual disclaimer applies. So as a motivating, I'm going to start with a few motivating facts for our paper. So the first one is probably well known within this room, is the fact that in many emerging economies, households hold a large share of bank deposits in foreign currency. And a large portion of these deposits is typically converted in dollar loans to non-financial firms. So if we look at the evidence for deposit dollarization and like do this scatter plot of the dollarization in 2000 versus 2018, we see that despite high heterogeneity and despite like there being like a downward trend in dollarization, as we see from the fact that there is the slope of this line is below the 45-degree lines, it's still like a relevant phenomenon in many countries. And the second startling fact that we're interested in is the fact that it's typically welfare households who hold a larger share of their savings in foreign currency. And this is a finding that has already been highlighted by Drenik in an ERPMP. And here we confirm this finding by using data for Uruguay, where they have like a nice household survey where they also record like the currency composition of their savings. And here we're showing the share of net liquid wealth in dollars as a function of the liquid wealth quintile. So we see that like richer households have a larger share of their deposits in foreign currency. So what are we after? The main question is, how does dollarization affect the aggregate and redistributive effects of devaluation in emerging markets, and what are the implications for monetary policy? And we want to look at this question by developing a model which can capture both some macro and micro facts, especially at the household level on deposit dollarization. What we do, so in a nutshell, we start by presenting some empirical evidence on how dollarization amplifies the effect of a devaluation on output investment and especially consumption, which is something sort of new. And then we develop a new Keynesian small open economy model with two new elements. So the first one is the presence of households facing an insurable income shock and borrowing constraints, so a Hank block. And then there is also going to be a leverage constrained financial sector, which lends both to households and firms. And there's going to be an important interaction between these two elements in our model. And the idea is that the deposit dollarization on the household side is going to result in banks' currency mismatch. And we can also use the model, though, to match the households' dollar deposit distributions from the data. And given this model, we're going to study the effects of a devaluation, which is caused by a higher foreign interest rate shock. So main results. So the first results is that we show that in terms of empirical evidence, we find evidence that dollarization amplifies the negative effects of a devaluation. Here we're going to focus on a devaluation caused by US monetary policy shock. And we show that extra 10% of dollarization amplifies the effect on output and consumption of about 15%, and the amplification is even larger on investment. Then we passed to our model, so we developed this novel type of open economy model, and we showed that the interaction between the banks, the financial sector, and the Hank generates new amplification channels for exchange rate shocks. And these channels are two, and they interact with each other. So the first one is what we call the borrowing rate channel. It comes from the fact that when there is an exchange rate depreciation, due to the currency mismatch on the bank balance sheet, this is going to cause a deterioration in bank net worth. So lending spreads go up, and this negatively affects the consumption of borrowers with a high MPC. And this is going to, we're going to do like a decomposition. This is going to account for about 1/3 of the drop in aggregate consumption in our model. And then there is also going to be another channel we call the labor income channel. And the idea is that lower bank net worth is going to result in lower investment, lower hour and wages, so in lower labor income. And this is going to be particularly detrimental for, again, for poor households with a high MPC. And this is going to account for 2/3 of a decline in consumption. Importantly, we saw that it's the interaction between these two blocks that matters for this amplification, joint amplification of consumption, investment, and output. And that absent one of these two blocks, Hank or the bank's block, the amplification would be much smaller. Next, we showed that an implication of the model is that as we increase dollarization, we're going to, by keeping the distribution constant, like so letting this dollarization may be driven by the richer houses, we have that this is going to result through these channels that I described above into a larger effect on consumption and a larger decline in investment, and the magnitudes in the model are going to be in line with the empirical evidence that I discussed in the first point. And finally, we discussed briefly the trade-offs for the local central bank and fighting depreciation, because the central bank is going to face a trade-off between raising interest rates and stabilizing the exchange rate, so limiting the negative effect that the currency mismatch has on the bank net worth and on the whole economy. But to do this, the central bank needs to raise interest rates aggressively, and this is going to depress asset prices and is going to negatively affect the net worth. So there are these two opposing forces that are at play. And what we show is that the benefits of exchange rate smoothing become relevant only for very high levels of dollarization. All right. So let me start from the empirical analysis. As a first exercise, we do a simple event study where we focus on currency crisis. We take these episodes from the classification of level and Valencia. These are situations when the exchange rate against the dollar depreciates sharply over 1 year. And we compare the behavior of output, consumption, and investment in two groups of countries classified according whether they have a dollarization which is above or below 25%, which is the median in our sample. And the idea of this simple exercise is to show that if we compare these two graphs, is that despite like a behavior of the exchange rate, which is the purple line in the graph, which is sort of similar, the drop in output, consumption, and investment seems to be much larger in countries with the higher deposit dollarization. Now, the devaluation and the currency crisis could be caused by different types of shocks, so we moved to do something more systematic. So we switched to quarterly data for 20. Yes.
Yeah, can I ask you?
Of course.
Just to understand, between these two countries, I was trying to see if you had inflation. So this is a nominal devaluation, and is the behavior of inflation similar among these countries?
We haven't looked at the inflation, so like I don't remember.
I'm thinking that countries that are more dollarized are because they have a history of inflation, so inflation may react differently to a devaluation.
Yeah, that's a possibility. We're not going to go after the drivers of the dollarization. So that's one of the leading explanations, that maybe you have like a lot of exchange rate volatility, of inflation volatility, that could be one of the drivers. What we're gonna be after is we're gonna go after the exposure. So given a starting level of dollarization, this is like dollarization the year before the crisis. So that's how we're classifying the countries. It looks like this type of currency crises are more detrimental in high dollarization ones. But the next experiment is a bit more. Yes?
I don't understand. The currency crisis, here is one day, the central bank goes crazy.
No, it's one.
Devalues, and then you look at, and then the countries are, for some reason, are more or less dollarized against this risk.
Yeah, so these are all the episodes when the exchange rate against the dollar depreciates by, I think their classification is more than 20% over 1 year.
Yeah, but there is a reason why that happened.
Of course, that's why we're doing the next experiment.
Affects everything else, right?
of course. That's why we're doing the next thing. So this is just like, but let's start with like an event study. These are like large evaluations. It looks like there is some difference there, but I get your point. That's what I said before. There are different reasons. So let's look at a specific reason, monetary policy shocks. So we look at quarterly data on 21 emerging economies between 1995. Yeah, I mean, that's fine with me. So we have, oh, it's getting fun. But anyway, I'll continue. So we use quarterly data on 21 emerging economies between 95 and 2019. And we ran panel local projections using as US monetary policy shock, the orthogonalized monetary policy surprises recently developed by Bauer and so on. So these are like shocks that are orthogonalized on financial and macroeconomic data that were released right before the FOMC announcement. And they're the latest one in this collection of high-frequency monetary policy surprises for the US. And we run this simple panel OLS regression where on the left-hand side, we have different variables. We're going to focus on exchange rate, output, consumption, and investment. So we run this regression at different horizon H for country I. We use country fixed effect, which is the coefficient alpha. And first, we look at the coefficient beta, which is the input response to the monetary policy shock. And we also introduce some country-specific controls, which is in Z. These are just two lags of the main variables we look at. And some US-specific controls. These include the GDP, inflation, Fed funds, and the BA spread. These are also the same variables that Bauer and Swanson use in their paper. So here we report the effect of a monetary policy, contractionary monetary policy shock that causes the exchange rate to depreciate by 1%. So we normalize the shock to have a 1% depreciation in the exchange rate. And we see that this shock causes a decline in output of about 0.5%, similar decline in consumption, whereas the decline in investment is quite larger. So, and even this is like a new type of exercise, but even though we use a different econometric methodology, the estimates that we obtain are also in the ballpark of other studies, for example, like Vicondoa in the GIE. But then in one important point here is that we see that the decline in consumption is of the same magnitude of the decline in output. Next, we augment this analysis by introducing an interaction term, which captures the interaction between the dollarization of the country 1 year before and the monetary policy shock. So now that coefficient gamma is going to capture the extra effect that comes from having a certain amount of dollarization. Here we're normalizing the input responses so that we are going to show the extra effect of an extra 10% of dollarization before the shock occurs. And we see that this coefficient, even though it doesn't seem to have a very significant effect on the exchange rate, it looks like it amplifies the effect on output and consumption by about 0.15% and by 0.3% on investment. So it looks like there is some evidence that dollarization amplified the negative effects of a US monetary policy shock in emerging economies. And we ran some robustness checks. We introduced other variables that could explain this, for example, trade openness or exchange rate regime, and we find similar results.
One question.
Yes?
The reaction, when you do this, the reaction function of the local central bank must be important.
We also have an extension where we control for inflation, the deposit rate. So, yeah. So that we also control for that, and it looks like it's
inside the Z, or
yeah. We have an extension where we put it inside the Z. It's in the robustness button. I don't want to click not to make a mess, but obviously with those are variables that we introduce also in one of the specifications.
Yeah, and it's important because if not, the error is correlated with the U, because it has the reaction of the interest rate to the U.
Yeah, but we use also that in the specification. The results look similar. All right. So
Quick question: do you know if that's specific to monetary policy shocks, Or you see the same amplification following a commodity price shock? Or
We haven't tried other shocks. So that's, so I don't know the answer to this question. All right, so let me jump to the model. So as I mentioned before, the model is a small open economy framework plus a Hank block and a banks and a financial intermediaries block. So let me describe quickly the new ingredients in the model. So households, they're going to face an insurable idiosyncratic income risk and a borrowing constraint, and they can be either workers or capitalists. Workers supply labor to a union, so we have homogeneous labor supply. This is a typical type of simplification in this type of models. Whereas capitalists do not work and they're going to receive profits from firms and banks. You can think of these capitalists as being the top 1% in the wealth distribution. Households can save in foreign bonds and in bank deposits that can be denominated either in local or foreign currency. But they can only borrow from the domestic bank. So this is an important assumption. Then we're going to have banks that intermediate funds across households, so from saving households to borrowing households, and they also lend to domestic firms. So here banks are going to directly hold capital. This is a simplification. So you can think of these banks as putting together both financial firms and non-financial firms in our framework. Banks that want to borrow using deposits both in local and foreign currency, but they're going to lend mainly in domestic currency. This is going to generate the currency mismatch that I mentioned before. And importantly, there is going to be an agency problem model like in Gertler and Karate, which is going to generate an endogenous lending spread, both on capital and on loans to households, and a leverage constraint for the banks. So let me go quickly. Okay, in the rest of the model, so we're going to have nominal rigidities in domestic and in export prices. So we assume DCP, which seems like it's the more realistic type of assumption for export prices, but this is an important assumption. I'll discuss it if I have time. We assume sticky wages. Production of new capital is subject to adjustment cost, and we're going to have variable capital utilization. So we combine some standard nominal and real rigidities in our new Keynesian model. Foreign block is going to be super simple. We're just going to introduce a demand for exports, which is a function of the terms of trade. The central bank is going to follow a simple Taylor rule, which reacts to domestic inflation. And finally, the main shock is going to be a shock to the foreign interest rate, which follows an autoregressive process. So the only equation I'm going to show you are going to be the ones related to the problem of the households and of the banks that are sort of like the non-standard agents in our model. So the households maximize a standard utility. So they have a utility from a consumption basket, big C, which is a composite of domestic and foreign goods, and this utility from labor. And they're subject to the following borrowing budget constraints. So on the left-hand side, we have expenditure in the domestic good and in the foreign good priced at PH and PF, plus household they can hold bonds or deposits either denominated in domestic currency, so that's the B tilde H, or in the foreign currency, that's B tilde F. And E is the nominal exchange rate. In terms of income, so as I mentioned at the beginning, household can be either workers or capitalists, depending on the realization of the idiosyncratic variable kappa I. So if kappa I is 0, the household is a worker, and if the household is a worker, it's going to get labor income W times H, subject to an idiosyncratic productivity shock, omega. So this is a standard Hank component. If the household is a capitalist, so if kappa I is equal to 1, instead the household is going to get all the profits that come both from the firms and from the banks. And then there are going to be the returns both on the domestic bonds and the foreign bonds. These are going to be bank deposits in our framework. And there is going to be a simple borrowing constraint, which limits the total real amount borrowed by the household to a fixed number, B bar. Now, importantly, in our model, households are going to face different interest rates depending on whether they save or they borrow. So let's focus, for example, on the domestic securities. So the return on their domestic asset or loan R tilde H is going to depend, is going to be given to, is going to be equal to RD, so it's a deposit if they save, so RDH, whereas it's going to be equal to RLH if they borrow. And the same is going to apply to the foreign denominated assets. And the important thing is that due to banks' financial friction, there are going to be endogenous spreads between the borrowing rate and lending rate, which are going to move over time. And these spreads are also going to generate a fraction, a sizable portion of the population, which are going to be agents that optimally choose to hold zero liquid asset and behave like hand-to-mouth agents. And these are going to, for the micro data that we use for Uruguay, this is going to be important because a very big portion of households have zero liquid wealth. Whereas we're not going to introduce any friction between domestic and foreign loans and domestic and foreign deposits so that the standard UAP condition applies. In terms of the bank's problem, so this is modeled following the Gerther and Karadi framework. So the idea is that there is a bank that discounts the future using the real rate. A banker's exit with the fixed probability 1 minus sigma b. And they face this agency problem where they can steal a fraction of their capital and a fraction of their loan, so that the value of operating their firm, as I'll show you soon, has to be greater or equal than the weighted average of the value of their asset. So the bank's problem is going to be to maximize the value of their net worth, NT, upon exit. So with probability 1 minus sigma, the bank exits next period, and with probability sigma, they continue operating, subject to a series of constraints. The first constraint is simply the balance sheet of the bank that says that the bank can purchase capital at price QK or hold loans. And these loans can be either in domestic currency, as shown in the second equation, LH, or in foreign currency, LF. And they can finance these purchases using their net worth, NT, and deposits, big D. And also these deposits are going to be either in domestic currency, DH, or in foreign currency, DF. So the evolution of bank net worth is going to be given by the return on the assets. So the first term here is the return on capital. Then there is going to be the return on loans that can potentially be either in domestic currency or in foreign currency, minus the realized return on deposits. And also in this case, we have the return in domestic and foreign currency. And importantly, the realized return on foreign currency deposits is going to move with the exchange rate. And finally, there is going to be the incentive constraint that comes from the incentive problem that requires that the value of operating in the bank is greater or equal than this weighted value of the bank's asset. Now, if we solve the problem of the bank, we're going to have the following first order optimality conditions. So first, we're going to have a leverage constraint on the fee. Fee is bank leverage. So which requires that the bank leverage is smaller or equal than a function of spreads on capital. So in our model, we're going to assume that this constraint is always binding. So this is going to be an equality. Then there is going to be an arbitrage. There is going to be like a condition that links the spreads on capital to the spreads on loans. And this is going to be important because this is going to imply that fluctuations in bank net worth imply a co-movement between spreads on capital, domestic capital, and domestic loans. Whereas again, there is going to be no friction between deposits in foreign and domestic country or loans in foreign and domestic country. Again, the UAP condition holds there. And finally, the last piece of the model is that the aggregate net worth of banks, again, is going to be equal to the equity of surviving banks plus a transfer coming from the capitalist. And again, the main idea here is that the return on net worth is going to depend negatively on the realized return on deposits, RD. And this return on deposits is going to be linked to the exchange rate fluctuation by the share of deposits, XD, that are in foreign currency. So the idea is that when there is a devaluation, the exchange rate depreciates, so it goes up, net worth goes down, the leverage constraint becomes tighter, so banks have to unload assets, offload assets, until the spreads go up enough so that this condition is satisfied. And crucially, since the incentive constraint applies to both loans and capital, the spread on capital and on domestic loans will have to move in tandem. Okay, so this is the standard financial accelerator, yes?
Do you add capital requirements for when the bank is mismatched, as we see in the data? Does the bank need to post equity when they're mismatched?
There is no extra requirement. There is nothing that regulates the capital mismatch in the model.
But
no.
in the data, it's quite strong.
That's something that we are planning to study, but there is not there is not there in the model, no, not specifically.
Because when you look in the data, the capital requirements make them have zero mismatched.
Yeah, the idea is that whether we're going to look, again, as I said, this is a simplified framework where you can think of the bank as putting together the firms and the non-financial and the financial firms, so that you can think of this as capturing both the implicit and the explicit exposure to currency mismatch, right? This is sort of the assumption that Banco Lorenzoni make, so that you can have that banks are lending in dollars, but there is the credit risk that comes from the firms borrowing in dollars.
Banks also have restrictions on the borrowers that borrow in foreign currency, because if not, they make a loan in dollars for a mortgage, and then they will, when there is a devaluation, they default. So the capital requirements in Basel III or the regulation is addressed to limit this currency risk.
Yeah.
Banks are better suited to hold this risk than the firms, but Basel III or the capital requirements don't allow them to do it, so they end up passing this through to the firm. But you cannot match them together, because it also depends on how good they are at identifying the firm's ability for currency risk.
Yeah, no, I guess like we can look more in detail at the country-specific regulations and how these are going to affect. But the idea is that at the end of the day, someone has to repay these dollars. So there are all these dollars there. So like what we're going to, the idea is that to show that a channel through which other the firms of the banks, they have to repay these dollars. So at the end of the day, it has to have an impact, like it is going to affect household. The idea is that to propose these two channels through which these repayments are going to affect households. But I'll be happy to discuss more in detail the details about the regulation.
Can I ask one question?
Of course.
Effectively, you call those operators banks, but actually is the aggregation of banks and firms.
Yeah.
Because there are no firms that are separate in your model.
No, for simplicity,
So
yes.
in some sense, it's just the consolidated sectors that is mismatch. So whether that mismatch comes from actual banks or firms, you don't take a stand.
I do not, exactly. They wash out.
So in some sense, it's compatible with the idea that banks actually, they are quite balanced.
Yeah, that's why I said, like, I'm putting them together and just saying at the end of the day, one of the two has to find the money to give back to the households. Like, they want dollars. But yeah, thank you. All right. So let me...
Clarifying question.
Of course.
In your model, your households have portfolio decision in terms, do they have interior portfolios in terms of savings and to types, etc.? I can't tell with all the different interest rates.
No, of course, no, because I didn't tell you that yet. So that's a good question. So given the way in which we are solving the model, which is like with linearization, the portfolios are not pinned down in equilibrium. But so the idea is that we're going to use we're going to match them using the distribution of deposits that we saw from Uruguay, and to calibrate a specific dollarization rate. I'll show you that in a second. But they're not. We don't have, as I said at the beginning, we don't have a story for what drives dollarization. Our idea is going to be, we have a model that can capture the distribution and the level of dollarization. We're going to look at the implication of this initial currency mismatch. All right. So briefly, in terms of the calibration, most macro parameters are in line with the standard Latin American country. An important parameter is going to be here trade elasticity, as discussed by Auclair and co-authors in a paper. They show that in this Hank framework, that's very important for whether the devaluation is a contraction or not. Here we take a value on the low end, but we discussed the results are robust to this in the paper. We look at in terms of the targets, we take a bank leverage of 6. So again, here going back to the notion that these are, we use a low level of leverage because we can think of this as being like a weighted average of the leverage of firms, where it's pretty low in banks. And we assume a spread of 10% for households, which is like with Uruguay, and 2% for capital. And then we calibrate the income process to match some microdata from the Uruguayan data. As I said at the beginning, an important, as we see from this data, there is a large share of borrowers, and there is a very big share of the population that are zero wealth households. So this is going to be important for our model. And for the portfolio, as Christiana was asking, since the portfolios are not pinned down at first order, we assume that there is households have a function X, which is the share of their liquid wealth in dollars, which is a linear function of their wealth. And we're going to calibrate these two parameters, eta 1 and eta 2, to match first the slope of the distribution of household dollar savings in Uruguay, and second, the share of foreign deposits held by banks. So here we use, in our baseline calibration, we use a dollarization rate of 25%, which is the median from our local projection analysis. And finally, we assume that households do not borrow in dollars, which is what is true for Uruguay. Okay. So given that our model is pretty rich, it's going to be useful to go through the propagation, through all the channels of the propagation of this foreign interest rate shock by going through a set of simpler models that are nested within our framework. Okay? So the main shock is going to be a tightening in foreign interest rate with a persistent of 0.85, which causes a 1% depreciation in the real exchange rate. Okay? So we're going to do this in step. So what are the channels through which this shock propagates in the simple rank open economy model? So we're going to have two standard channels. We're going to have the intertemporal channel, which comes from the fact that higher foreign interest rates increase the desired saving for households and firms, so they drive down investment and consumption. So that is a negative effect on output. But then there's going to be, on the other end, the standard expenditure switching channel, through which exchange rate depreciation pushes up net exports, and this can push up output. Okay, so there are these two opposing forces. So these are shocks. So the real exchange rate appreciates by 1%. Now, given our calibration of low trade elasticity and of DCP, we have the net exports go up, but by not much. Whereas on the other end, investment and consumption decline, and this second force dominates, and we have a small contraction in output. Okay. Now let's introduce banks in this framework. What happens? There are two extra channels. So first of all, we have a standard financial accelerator channel. And the idea is that funding costs go up, interest rates go up, asset prices go down, in this case capital, that's what I have in mind. So bank network declines and investment go down, and this pushes down output. So this is like an amplifying force. And this force is even strong if banks have a currency mismatch, because on top of that, first effect, the negative first effect on network, there is also going to be the negative effect coming from the currency mismatch. So if we look at the same shock in this model, in this rank model with banks, we see that now investment drops quite more, and so the decline in output is larger. Okay, and the idea is that there is a declining network, and the spread on capitals opens up, and this drives a larger decline in investment. Okay, this is standard financial accelerator channel. Now, what if we take the Hank model without banks? So if we put the heterogeneous households in our framework. So first, there is going to be this labor income channel, which is related to what O'Clair and co-authors call the real income channel. It comes from the fact that given that output is going down in the baseline economy, we're going to have also a decline in the real income, in the real labor income for household. It comes from the fact that hours go down, wages go down, and wages are denominated in local currency, so that we have the real labor income goes down. And so this is going to affect negatively the consumption of IMPC households. So this pushes consumption down. And then we have several other channels that are weaker, though. So we're going to have a Fisher channel, because this devaluation is going to cause a devaluation of households, potentially positive on impact. And also there is going to be household currency exposure, because here we have all these rich guys with dollars that are going to benefit from the devaluation. However, these guys have low MPC. So they're going to have a positive effect on consumption, but it's going to be small. So in general, if you put all these elements together, in the red dashed line, we see that this labor income channel coming from the fact that output is contracting and labor income is going down causes an amplification in consumption, okay? Now, finally, let's go to our baseline model. So let's put all these elements together. So we have these two new extra channels. So the first one is what we call the borrowing rate channel. So now the declining bank network is going to cause not only the spread on capital to open up, but also the spread on households' loans. So this is going to affect negatively the consumption of IMPC households. And on top of that, we also have that the financial accelerator on investment is going to depress hours and wages and labor income. And even this is going to be detrimental for IMPC households. So now when we put everything together, we see that in our baseline economy, which is the blue line, so we have declining network, spread on capital opens up, but also the spread on loans, which didn't have any role in the other models, opens up. And the declining in investment is going to feed in lower labor income and in a much larger decline in consumption and output. Okay? And we can look at these effects by studying the behavior of consumption of different groups of agents. So here we have the constrained borrowers, the unconstrained borrowers, the zero liquid wealth and to-mouth agents, the unconstrained savers, and the capitalists that are just the 1%. And so we see that the bigger decline, and we're comparing the blue line, which is our baseline, with the simple length model without banks. And we see that the bigger decline in consumption is driven by the much larger decline in the consumption of high MPC agents that comes both from lower real labor income and from higher interest rates on their loans. Okay, so the magnitude of the effect of the shock is similar in our model as in the data. This is just the unconditional effect. But let me now discuss briefly the effect of dollarization. So what I'm doing here, I'm replicating the same exercise. The blue line is the baseline economy. And then I'm doing the same exercise by using different levels of dollarization. So the purple line is zero dollarization, red line is 10%, and the black line is 50%, so higher dollarization. So as dollarization increases, we see that the effect of the interest rate shock is amplified. And this comes from the fact that all the channels that I described below, the spreads and the labor income, are amplified as well. And interestingly, if we compare the effect of an extra 10% of dollarization in the model, the blue line, and in the data, which is what I showed you at the beginning of the presentation, we see that the magnitudes are fairly similar. Whereas if we do the same exercise with the rank model with banks, which is the red dashed line, so we see the model can get amplification of dollarization on investment, but it cannot get much on consumption. And importantly, if we take a Hank model without banks, which is the purple line, the effects would go the other way. You would actually have that consumption goes up more and more. And this comes from the fact that if you don't have banks, obviously giving dollars to households is going to insure them from the depreciation. There's no negative effect there. So this sort of tells you that the interaction between these two elements can be important for capturing this finding that we have from the data. Also, briefly, in terms of quantifying the different channels, we can do in this type of Hank models, you can do sort of like a partial equilibrium exercise where you feed through the consumption block different prices from the model. And we see that the purple line is the effect of only feeding the borrowing rate channel, and the red dashed line is only the effect of feeding only the labor income channel. And we see that the labor income accounts for about 2/3 of the big decline in consumption, and the other remaining 1/3 comes from the borrowing rate channel. And again, you can see that the labor income account basically the main driver of zero wealth and to-mouth agents, because they don't borrow, they only have labor income, whereas the borrowing rate channel explains a lot of the fluctuation in the consumption of constrained and unconstrained borrowers. But if we do another type of exercise where we simply assume that the spread on loans is fixed, we see that the effect on the consumption is half as big. So here the idea is that in this exercise we're also capturing the feedback effect between the spread not moving and the labor income decline less. So this sort of captures also the general equilibrium forces that come from the borrowing rate channel. Okay, last exercise that we perform in the model. As I mentioned before, the central bank can potentially fight the depreciation by raising rates. So we augment the Taylor rule with the coefficient kappa I on exchange rate depreciation. So the larger kappa I, the more the central bank, the local central bank is going to find the depreciation. As I mentioned in the introduction, we're going to have two opposite effects of this force. On the one hand, stable exchange rate, they dampen the role of currency mismatch, but on the other hand, higher interest rates are going to lower aggregate demand and cause asset prices to decline, and this is going to amplify the financial accelerator channel. So we do is that we plot here the welfare of the different groups of households and the average welfare in the economy as we increase this kappa I, so how reactive the central bank is to exchange rate fluctuations. And we do this in our standard calibration with 25 dollarization, the blue line, and we repeat the exercise in a calibration with high dollarization. This is, I think, 80%. So we see that for low dollarization, there is no gains, no agent gains basically from exchange rate stabilization. This comes from the fact that the negative effect of lower asset prices and lower net worth of the financial sector are too strong. Whereas only if we have very high level of dollarization, then some level of response to the exchange rate fluctuation can be beneficial in terms of consumption volatilities for many agents. Okay, so let me conclude. So we developed a small open economy Hang model with financial frictions and the foreign currency deposits held by households, and we showed that this framework can introduce new channels for the propagation of a devaluation shock that come from the interaction between the currency mismatch of the savers, the bank, and the behavior of borrowers. And finally, we showed that central banks face a trade-off between smoothing exchange rate fluctuation and exacerbating the effects of banks' financial friction when trying to fight a devaluation. Thank you.
Yes, thanks. Thank you to the organizer for giving me the opportunity to read this interesting paper. I will comment on this, on some of the main ideas on the paper. Let me see. Yes. Just a brief recap on the main ideas on the paper by Francesco and his co-author. They are trying to look at the effects of the depreciation of a local currency in an emerging market and see if there is an impact on output gaps or output cost of the depreciation. The main idea was that there is currency mismatches on the banking sector that will cause some decline in the bank's net worth that would affect the supply of credit and will amplify the effects on the economic activity. Then there is a larger currency hedging by wealthier households. There is a heterogeneity in the households, so the wealthier households will hedge on their FX risk, and that will amplify the effect on the output cost, on the output activity from the economy. Finally, they talk about the foreign exchange intervention, which they will have some welfare gains if there is a high degree of financial dollarization. And that large financial dollarization, they mention it's around 80%, which is indeed quite large. So we will comment on that a little bit later. there are some novelties on the paper which I like, which is they mention the leverage constraints on the banks. So actually from the question that you asked during the presentation, that's indeed something interesting because they are concentrating the currency mismatch on the banking sector. Through that mismatch, they have an endogenous spread on the interest rates, lending and savings rate. So through a borrowing channel, they will explain that the depreciation will amplify the effects because the banks will cut on their credit supply. But there is also some specific, an interesting feature, which is the heterogeneity on the households, which will also affect the output activity through this labor income channel that they describe on the paper, which is quite interesting. But one result that is surprising, I would say, is that the heterogeneity in the households will generate an impact on the poorer households, which are not directly exposed to the FX range, exchange risk, which is quite a novelty, I would say, on the results. And this heterogeneity in the household will also amplify the effect on the economic activity and on the distributive effects within the household, which is quite interesting. So that's just a brief recap of all the main results on the paper, but I will comment on some of the assumptions. Actually, when Francesco was presenting, you were also asking about some of them. Of course, there is always, when we model something, there is always that discussion how much we should make the assumptions reality, close to reality. So you have some trade-off on that. I think that the paper goes from some basic modeling and then expand on them, taking into account some considerations. They say they capture some stylized effects on the emerging markets, the dollarized emerging markets, which is, I would say are okay. They make some standard assumptions with the calibration of the modeling, which are okay, but they add these novel ingredients, which is the currency mismatch in the banks and the heterogeneity in the households, which are okay as well. But I will comment on a couple of assumptions that I would say they would need some more discussion on the paper. Actually, the one on the firms having the currency mismatch, they mention it on the footnote that they have studied that previously, and they now consider only in the banks the currency mismatch, which are okay, but because they refer to a previous paper on that, I would say that there would be better place in the text rather than in a footnote to consider that. Because if the banks are also subject to some macro financial regulation, they will not carry the currency risk. It would be the firms that will carry the currency risk. So those firms that borrow in foreign exchange currency, in foreign currency, they will have the currency mismatch and they will provide this mechanism that will expand the effects on activity. But they don't discuss that directly. They say that they have done that previously, and in doing that, they consider that in this paper, with the banks having the currency mismatch, they will provide an indirectly they will include the financial mismatch in the firms. But I guess that needs a little bit more discussion, I would say, in the paper. And then another thing is that there are no specific channels for the non-resident investors in these emerging markets, because these non-resident investors will add some huge movement in the exchange rate, not necessarily only through responding to international financial conditions, but also to some local conditions. So non-resident investors will also add some considerations in this modeling that I guess will be nice to discuss as well. Again, this topic on the macroprudential regulation on FX risk, banks are usually highly regulated on this. So there is an issue there, because if the main idea on the paper is that this currency mismatch is placed on the banks, but if these are regulated so that they don't carry that much financial risk or foreign exchange risk, then what about the effects? Are they not functioning if they are regulated heavily on the FX risk that they are allowed to carry? And also, if the firms are the ones that have the currency mismatch, there is also some experience with emerging markets that the firms have also learned from experience, and they know how to manage their FX risk. So they use, for example, derivatives hedging for hedging away their financial risk or their FX risk. The banks usually focus on their long-term net financial risk, FX risk. So they don't change that frequently in the short term. But if you have the currency depreciation in the short run, probably the effect would be not that amplified in the modeling. But I'm not quite sure about that because of the model which have built upon assumption after assumption. When you read the paper, you have the idea that you have the sensation that there is a bad thing, and that bad thing is the dollarization. So how much of a bad thing we should have in these emerging economies? Because if you have a currency depreciation and then the effect on output activity is quite large and it's amplified because of this financial dollarization, then you should conclude that you should erase all financial dollarization. But in the first place, there is actually financial dollarization in these economies. So if there is any benefit on that, I wonder, and this is a question for Francesco, please. I wonder if there is symmetry, some symmetry in the results. If there is a currency depreciation that is amplified through this borrowing channel and labor income channel that amplifies the effect on the output, what about currency appreciation? Would have the opposite effect? That would mean that there is a benefit effect from a currency appreciation that will expand activity more than in any other case. So I'm not quite sure about that in the modeling, but that should be quite worth discussing in the paper, or at least mention some of that, which is the final comment over there. Also about the forest intervention, which is quite interesting, the results from the paper. I really like them. Because, you know, some 3 decades ago, financial intervention, foreign exchange intervention was not a good thing. In the last couple of decades, we have been discussing in Central Bank that that's something that happens, and it's good to have financial foreign exchange intervention. So the paper concludes that there is a some degree of foreign exchange intervention that could be worth having, especially if there is a high level of dollarization. But that's 80%, which is quite large indeed. So many other countries that have a lesser extent of deposit dollarization intervene in the markets, in the foreign exchange markets, and that could probably argue, or we could probably argue that that's something that it's beneficial to those emerging economies. There is no distinction between the type of intervention that central banks have, whether they intervene on the spot market or they intervene on the derivative markets. That could add some specifications to what is beneficial from that. There is a discussion about the threshold that we should keep intervening in the market, so that's also something interesting. And just some concluding remarks. The key issue is here who holds the FX risk and how they hedge away the risk if that's the case. It's either the central bank, it's either the banks or the firms or even the households. I think that for that, we have experience, or this agent have the large experience in the recent years about that. So let me conclude with that. Thank you very much for the attention. Thanks a lot.
Let Francesco reply a second to the discussion, and then we'll start with the questions.
All right. Thanks a lot, Alberto. These were all super interesting points. Let me start from the one that was also the core of the discussion with the presentation. So banks versus firms mismatch. You can shut down the banks completely in my model that I showed you, and the real labor income channel, which is 2/3 of the movement in consumption, is still be there. So you can make this paper, if you want, about just firm currency mismatch, and like 2/3 of the results are probably going to be there. So then also it's this discussion about banks being regulated. So I understand that they have to match deposits to loans, but it doesn't mean that they are like edged from exchange rate fluctuation. Just have to match it, but it doesn't mean that they're edged. And following up on this edging discussion, this is obviously crucial for our paper. And I'm not. I mean, probably the people in this room know much more about than me about like FX hedging in Latin America. But from my understanding, firms don't do much FX hedging. So I thought, like, from the few papers that I read, FX hedging is sort of rare. So I don't think it's going to like take away the currency mismatch problem, at least from the non-financial sector. I think maybe Juliana, you have something in your paper, no? Okay, sorry. Let me see. About the asymmetry, that's a very good point. So given the way we're solving the model, it's true what Alberto said, that like an appreciation would be beneficial with currency mismatch, but it's possible that the negative effects of the currency mismatch are non-linear. If you think that this financial constraint on banks, they're not always there. Like you have like some extra effects like bank runs or this type of financial panics that give you like extra effects in bad time. So the asymmetric question is obviously very valid. They are symmetric given the way we solve the model, but they don't have to be. And FX intervention, that's something that we definitely would like to look into. We'll be happy to chat about it later.
So I was going to say, it does matter. Like banks are not mismatched. So there's a paper by Tobal who talks about all the capital requirements. And this is not only in Peru, which I know they're not because I have studied it, but across all these dollarized economies. It does matter where it's coming from. So what happens is you have deposit dollarization. It gets pushed through to loan dollarization. So it's true that the banks are going to be passing through that risk to firms. That doesn't mean you should shut off banks. Because what my work, theoretically and empirically, with Liliana has shown is that the ability to allocate credit in dollars or foreign currency that allows firms to finance at a cheaper rate and then increase their investment is going to be crucial, or whether or not they can handle a depreciation. So what I want to say is that the allocation of these loans is going to be crucial to see the impact of it. So banks are important, but banks are not mismatched. And it's true, firms are not going to be hedging with derivatives. I know that in many countries they don't because it's very costly and they don't understand exactly these instruments well. But it doesn't mean that they are fully exposed as long as you have a good bank that is able to allocate efficiently these loans to those firms that are able to handle that risk and are able to finance at a cheaper rate. So I'm going to echo what the discussant said, that placing dollarization or foreign currency loans as a bad thing off the bat, it's not okay.
In the particular case of Uruguay,
yeah,
the capital requirements depend on the currency mismatch on the bank's balance sheet, but they also assess the credit risk of the bank because of the currency mismatch of the borrower to take care of what Juliana was saying. And
but this is, yeah. This is,
and in some way, I think that you can look at the data on the banks and the corporate sector, but it's not easy because, for example, I was just talking to him, like typically banks have a restriction that they can lend in dollars to produce to exporters, but then the exporters have liabilities in pesos as well because they have to pay wages. So they might be, so these exporters might be, as your rich people, even if they have a debt in dollars, maybe the revenue in dollars that is not in the balance sheet, but it's the future cash flow, is hedging that debt. And then they might have a positive effect on their net worth because of the devaluation in the same way as your rich households.
So, okay, so we had this in the model, so it's a point raised by Claire, due to DCP. So when you have like, this is the export in dollars, like the firms, his profits, they all go to this rich household, the top 1%. So if you,
Yeah.
if you remember, I don't know, probably it was too fast, but like
Yeah.
dividends, like the profits for this household also go up.
Yeah.
It's like what Auclair and Cotters call the profit channel. But given that we dump them, give them to the very rich guys, they don't have much aggregate effect.
Yeah.
In terms of the bank regulation, from what my understanding is, the discussion is that capital requirements are going to be adjusted. So let's say that this is going to play a lower leverage for bank. And we are using like quite a low leverage as well. But then this is going to be the actual exposure is going to be there. So the capital requirements, they're only macro proof. They can tell you like the leverage is to be lower, and we have like a leverage.
No, but I would check the data.
Yeah.
My hunch, like in Paraguay, they are not in Argentina, they are not here in Peru, they are not. My hunch is that if you look at the bank exposure, it's going to be low.
Yeah,
And
the
if you look at the firm
exposure,
exposure, it might work the wrong way.
way is tricky, but someone has to
Like,
pay these dollars at some point. That's the key. When during the depreciation, they want the
If,
dollar.
if they only go to the exporters and the exporters benefit from the devaluation.
But I think it's not only the exporters. Like there is like a paper. I think in Peru also, like it's not only the exporters. There's a paper like by co-authors. At the Fed.
They don't.
Saving dollars as well, so they're driving some of this dollarization as well. So they can be matched, maybe not through hedging and financial. They can
So, sorry, I'm going to interrupt you guys. You can continue the discussion afterwards. I don't know, Federico had a question from the beginning, so I want to finish with that.
Yeah, Francesco, now we're basically in this audience, you're getting the same kind of comments, which is that, I mean, we suffer so much about with the mismatches in the 90s that the regulatory framework in the 2000s changed completely. No, I would say Latin America, but if you go to Armenia or Georgia, which are also dollarized countries, the same. No, this idea that you don't allow banks to have a big mismatch and you only give loans in dollars to exporters. Latin America, not in Georgia and Armenia, where they actually give like mortgages in dollars. So you have a little bit there. But so we have this feeling that this mismatch thing, at least in Latin America, has been a little bit contained. Now, if you shut the banks in a theoretical sense, okay, which is I think what you meant, if you look at Argentina, for example, the Argentines have 1 GDP of savings abroad. And because everybody buys dollars, the ownership of dollar asset is actually very spread out throughout the different heterogeneous agents in the economy. So, I mean, you may want to think a little bit about that in the sense that you have actually the society is very long dollars, and you have like a huge positive net wealth effect for those dollar holders. You don't need to answer. I mean, it's just general comments on.
No, of course. Like obviously, like it's possible that these problems become less severe over time. That's totally the case. Our point is mainly like to highlight new channels of the internet, and also like something that can help this big decline in consumption with monetary policy shock, which is something sort of new, and there's a possible chart that can help explain that. But we don't make any statement. It's completely possible that these channels become weaker over time. I'm not making a trend statement. That's totally possible. Thank you.
Thank you very much. Okay, so we're gonna get started. So we have our last paper of the day, and we're gonna have Fernando Arce talking about tax revolts and sovereign defaults.
Thank you very much, Christina, and thank you very much for including this paper in the conference. I know I'm the last person between you and dinner, and this paper is about conflicts, but don't take the conflict with me. Let's keep it on the paper. This is with my co-authors, with my colleagues at the Chicago Fed, Nicholas Verkin and Jan Morgan, who's an excellent array we had. So usually we observe that when countries try to change the tax code or perform a fiscal consolidation, there are large protests that follow. Like a very recent example was France, but we have observed this in a lot of countries, and especially in a lot of emerging economies. And countries that tend to care about fiscal consolidations are countries who also tend to default as well. So the sovereign default literature has explored the effect of this, of a lot of political concerns, but the specific role of conflicts and social conflicts and protests hasn't specifically been studied, and this is where this paper fits in. Why look at protests and not just focus, let's say, on elections when we're thinking about sovereign risk? There's a few qualities that protests have that make it particularly interesting that they could interact with sovereign risk in multiple ways. One of them is the frequency. They tend to happen at a much higher frequency than elections, and these frequencies are consistent with the frequency at which we observe interest rate spreads, for instance. Protests are also costly for all parties involved. They tend to involve days lost from work. They tend to cause disruptions and lower output for everybody involved, both for the protesters and for the people who don't participate in the protests. And this makes that staging them and organizing them can create strategic considerations, both for the organizers and for the government who may be trying to change the fiscal policies that it wants to implement to try to prevent policies, basically being constrained politically by the streets. Moreover, there is also empirical evidence, both from emerging markets and from the US, that governments that tend to have a lot of protests and demonstrations during their tenure, they don't win re-election. They tend to become less popular, and we're not claiming causality in either direction. We think these things may be going in all of the directions, and the model is going to be able to study all of the potential causations and correlations that can happen between protests and sovereign risk. So, but because they change the re-election prospects of the government, they may also be very important for foreign lenders who may be thinking who's going to be in power and who's going to be making the default decisions in this country in the future. So what are we going to do in this paper? We're going to take the standard Arellano-Itungosovic model. We're going to add a few features. We're going to add the heterogeneous workers framework and nonlinear taxation from Heathcote and co-authors, commonly known as HSV. And we're going to also embed a political economy model of civil conflict dynamics that is inspired by the work of Acemoglu and Robinson, and in which agents are going to be able to respond to the government's fiscal choices by organizing protests against the government. We're going to calibrate the model to Argentina between 2015 and 2020 during the presidency of Mauricio Macri. This is a period in which there was a lot of protests. And what are we going to find? We're going to find that, as in the data, political and fiscal crises tend to go hand to hand, meaning that periods of political upheaval and protests tend to happen at the same time as which spreads are rising. The model is going to be able to replicate that feature from the data. We're also going to find that protests can increase default risk by making more likely certain political transitions that tend to coincide with defaults. Specifically in the model, it's going to be a transition from a right-wing party to a left-wing party that's going to start its tenure by immediately defaulting on the debt. I'm going to try to understand why that happens in the model. We're also going to show that protests can also lower default risk because they can actually act as a deterrent for a government if they tend to happen more during defaults. Basically, a government concerned about staying in power, if it anticipates that defaulting is going to trigger more protests against him and could potentially kick him out of power is going to be more careful and may decide to stay on the contract for a little bit longer, which could potentially lead to sustaining higher levels of debt and lower spreads. There's obviously a very vast literature on sovereign risk and political risk that was started by Leonardo and co-authors. The original literature focused a little bit more on models with representative agents. And relative to this literature, we're going to introduce a redistribution motives. The different parties in power are going to have different preferences for redistribution. And we're also going to deviate a little bit from this literature by assuming that the two parties are going to have exactly the same discount factors and the default costs. So whenever we're going to observe different tendencies to default by parties, these are not going to be driven by exogenous differences in preferences for default or discount factors, but by other considerations that we're going to explore a little bit more. We're also not the first ones to obviously think about inequality and political risk. The original Quadra paper of 2008 had heterogeneous agents, but it was much more a pie splitting problem. And we are going to introduce this efficiency equity trade-off in which the government is going to be able to redistribute, but splitting the pie in a more equitable way is going to mean a smaller pie. And that's going to have important implications for sovereign risk and for the interaction between political turnover and sovereign spreads. We're also going to introduce standard features of quantitative features of sovereign debt, such as long-term maturity, and which are going to matter when we're thinking about the tenures of different governments that tend to be more than one period, which also matters for when you think about political turnover. And yeah, relative to the political economy literature on macro impacts of regime change, we're going to keep the focus on sovereign debts, on sovereign spreads, which is something that this literature hasn't looked at. Okay, so what about the empirical evidence? Well, we're going to start by doing what the literature does, and we're not by no measure the first people to do this. We're going to look at this International Country Risk Guide, which is a think tank that provides this index for investors who may be interested in investing in emerging economies. And this think tank tells them, okay, this is the country risk, this is how likely we think that this is what how we're assessing the political situation in the country, how unstable the government is. Some of their sub-indices are government stability, internal conflict, external conflict, exactly the type of things that we're looking at. It's important that this index, they don't tend to look at financial or economic conditions. They have another index for that, but this one is all about politics. This index exists for across countries, and also has been found by the literature to have a significant effect on spreads even when we control for fundamentals. And we're going to replicate that result. We're also going to build our own data set. We're going to build our own data set for Argentina, looking at this data set of newspaper articles compiled by Dow Jones Factiva. We're going to scrap in the newspaper's articles for keywords like protests, strikes, revolts, and we're going to keep manually only the protests that are related to economic conditions, either tax reforms, fiscal consolidations, or in the case in Argentina, usually protesting against inflation and things like that. And we're going to also compile how many protesters the article estimates were involved in protests around that period. So what do we get? Using the cross-country evidence from the political risk, we find exactly what the literature has found. That even when you control for external debt to GDP, the current account to GDP, reserves, growth, and the primary balance, this political risk index is still significantly explains part of the spreads. We also try with different fixed effects, and as I said, this is something that there are other people in the literature has found. Another way of looking at this is if we focus on an event analysis. Basically here, what we're doing is we focus in an episode in which this index of political risk increased by more than one standard deviation, and we looked at what happens with the spreads. We see that the spreads also tend to go up at the same time. So this is the notion that political and fiscal crises tend to go hand to hand, and we're going to try to build a model that can speak to these facts as well.
Can I ask a super quick question?
Yes.
Is this something like, say, when you're getting close to elections in the US, does the index go up? Is this, or is this something else going on? Or it's just more about
No, so usually, so political, so in fact, political risks tend to go down just before before elections, because what they are assessing is how unstable the government is going to be, or how likely.
This is not the thing. Okay.
This is not transitions, but okay. So what about our new data set? So this is our new data set at the quarterly frequency for Argentina between 2007 and 2020. We have extended it now all the way to 2000. We're gonna try to do the 90s next. But as you can see here, you can see the dots represent the number of protesters involved in that quarter. We separate the protests by protests and strikes, or both, if those happen during that quarter, and we separate the two the presidencies by the dotted lines. The shaded areas represent periods in which Argentina was in default. So this is the period in which we're going to calibrate the model. This is the Macri presidency. As you can see, it was very tumultuous. So what I want you to get from this fact, and that we're eventually going to try to calibrate the model too, is to the fact that there tends to be more protests when the right is in power, at least from this picture, but also there's a lot of protests during defaults. And we're going to try to, we're going to have a model that can generate those things as well.
But just to be concrete, what does it really mean that it was very tumultuous during Macri? That there's a lot of people...
The concentration of points and the size of the points here.
No, I got, but...
Okay.
But if you go, what do they measure and say, okay, yeah, this is a moment that the index should be going up? What is exactly that they
So this is not from the index. This is us on the newspapers articles. This is not from the index. This is us literally reading newspaper articles and counting how many protests there were. That's where the y-axis is. And the size of the dot is in the newspapers articles, how many people they say they were involved in the protests.
Okay.
So this is, so because that index was black boxy, we decided to collect our own data. I don't know what the people in the think tank do, but that's why we decided to do this. Okay. So you can see also that...
A quick question. You mentioned this is your own data, but I was wondering if there is, you have, the most of the events are from both, from protests and strikes. But I was wondering if you have the actual, is there a difference between an announcement of the strike or this is the strike itself?
This is the strike itself. This is the strike itself because we have a number of people who participated in the strike. So we can get this also at the daily frequency. So this is zooming in during the Macri presidency. You can see that at the beginning of his term, he negotiated a deal with the lenders and Argentina was allowed back into the markets. There were a lot of protests that happened in the beginning. At some point, the index of political risk and the number of protests started to going up at the same time as the spread started going up. And then once we get towards the end of his presidency, we had to change the scales because the spreads keep going up and up. Now we're getting to 2,000 basis points. And what we observe is that at some point there are primary elections. The lender starts anticipating that Macri is going to lose re-election, and indeed, when the election comes, Macri loses re-election, the left comes back to power and immediately defaults on the debt, which is something that the model is going to be able to replicate as well. Okay, so now let's go to the sovereign debt model. So we're going to have a model that's a bit convoluted, has a lot of bells and whistles, but it has a lot of like standard features little by little. So we're going to have a government that can be controlled by two parties. We're going to denote those parties left and right. The parties are going to have a different taste for redistribution. And that's going to be the only difference between the two parties. The left-wing party is going to prefer the poor, and the right-wing party is going to prefer the rich. And by poor and rich, I also mean people who are more or less productive, and I'm going to denote them also as left and right. Basically, the preferred constituency of the left, the preferred constituency of the right. When you are the party in power, you get to make the fiscal decisions. Basically, that means that you get to decide if you want to repay the debt or not, the default decision, but you're also going to make decisions about the level of tax progressivity and the level of debt issuances. That we're going to call the fiscal packages. After the government makes the fiscal packages decisions, we're going to have households that, as I said, are going to be heterogeneous on their labor productivity, and they're not going to be silent, especially the households who are in opposition. So when the right is in power, the left households are going to get to play, and vice versa. And what does it get into play mean? The households are going to decide if they want to revolt against the government or accept the fiscal packages. Revolting is going to induce a cost for everybody involved in the economy, but it's also going to come with potential benefits in the future by decreasing the likelihood that this government that you oppose stays in power. So the firm is gonna, we're gonna also have a firm that combines the labor of both types of households and is gonna hire both households. And we're gonna have lenders that are pricing the government debt, and they're gonna understand that the price of government debt also depends on whether or not there was a revolt. So production is pretty straightforward, it's very off the shelf. We're gonna have the CES production. A is gonna be the TFP shock. And alpha is going to tell us how does this TFP shock is going to depend both on the default decision of the government and also on the revolt decision of the households. These are the pre-tax wages that the low-skill and high-skill households are going to get. The only difference between the left-wing households is that theta L is going to be smaller than theta R. This is what makes you rich or poor. But as you can see, the wages are going to depend on the total TFP. So both pre-tax wages are going to depend on total TFP, but also on the individual productivities. The only exogenous aggregate shock that we're going to have is this TFP shock. Okay, so
super quick. You want me to think about the data you show as revolts or indications of future revolt?
No. So this R variable is going to be whether or not the households did revolt.
But
or
I mean, when you did this data in the newspapers, that's revolts?
Yes. So
you think about as revolts?
We're going to think that in the data, when we're going to discipline this, we're going to say if there were more than 100,000 people, cool. That's a revolt. That's a quarter with a revolt. Okay. So the government state space. The government wakes up and observes the TFP, the aggregate TFP of the economy, its initial level of debt. And with this backlash I, we're signaling what's the type of the government in power. So this can be a left-wing government or a right-wing government. This is the type of the incumbent. The government chooses whether or not to default and the taxes that are going to be picked. And I'm going to explain you a little bit more about how the taxes work, but we take this completely off the shelf from HSV. So if you default, you are kicked out from international markets, but you still get to make the tax progressivity decisions. And if you repay, you make the tax progressivity decisions, but also the borrowing decisions. So how do the taxes work? And this is where it would have been good to have the buttons, but we don't. So let me explain you very quickly. So this tau1 parameter is going to control the level of tax progressivity. By varying this tau1, you're going to be changing the labor supply that both households make, and actually it's going to directly pin down the labor supply, because we're going to be assuming that the households have log consumption and a free elasticity of labor. So the tau1 is directly going to pin down the labor supply and also the size of the pie. This is the equity efficiency trade-off that I mentioned. The other part of the tax structure is going to be this tau0, which is the tax level. So the tax level, we're going to make it be whatever it needs to be such that the period budget constraint of the government holds. Because the price of the debt is going to be determined by the revolt decision, at the time the government makes its fiscal package decision, basically the progressivity and the borrowing, it doesn't know if the households are going to revolt or not. It has a good idea, it can predict it, it understands the probability of revolts, but it doesn't know exactly. So the tau0 is going to be there to fix, to make sure that this period budget constraint holds. Okay, so let's go over a quick example of what happens if the government decides to repay. So the government decides to repay, it has to decide the fiscal packages, the borrowing and the tax progressivity. We're going to have a Tay shock drawn from a logistic distribution in the same spirit of something that Pablo presented today. And the fiscal package decision plus the aggregate shocks are going to be combined into this variable, aggregate variable SH, which is the aggregate state that the households are going to observe. And this aggregate state is going to determine what's the probability of a default. The probability of a revolt. The government is going to understand that different fiscal packages involve different probabilities of social upheaval on the streets. And it's going to take that into consideration when choosing the fiscal package. Okay, so taking the expected probabilities of revolt, the government also takes into account its own welfare weights. This is the welfare weights that a government of type I has for households of type J. So both parties are going to care about both types of households, but the right-wing parties are going to care more about the right-wing households. So this is the static utility that the households of type J are going to get when the government makes the fiscal policy decisions involved with SH. And the static utility also is going to depend on the revolt decision. And of course, there's also going to be continuation values that are going to depend on the fiscal decision and on the revolt status. So we're going to try to unpack now this the current period utility and the continuation utilities for incumbents of party of type I. So suppose the government repays and the households decide not to revolt. Well, in that case, production takes place normally. We just use the TFP shock that we got. The wages are high. The pre-tax wages are high. This is the static utility the household get. No? So it depends on the tau 1 the government picked, and we use that tau 0 for the households for the aggregate tax level. So if there's a stability, the probability of the incumbent staying in power is going to be given by this pi r0, which is the probability of staying in power when there is no revolt, and that's going to be higher than the probability of staying in power when there is a revolt. So, okay, what happens when there is a revolt? TFP is going to be penalized by this red component, so pre-tax wages are going to be lower, but there's going to be a higher chance of a political turnover. The probability that the government stays in power is going to be lower next period. That's from the point of view of the households, from the point of view of the government. From the point of view of the households, when they are making this revolt decision, they're going to be comparing the value they get from revolting versus the value they get from accepting the government's fiscal package. On top of the aggregate states of the economy, that revolt decision is also going to be driven by this chi shock that's also going to be taken from an extreme value distribution. That's going to mean that, and it's not observable by the government ex ante, which explains why the government only knows the probability of a revolt, but doesn't know exactly whether or not the households are revolting or not. So from the point of view of the households, revolting involves a cost today because of this drop in wages that we explained, and there's also going to be a different tax level that could potentially be negative for the households. But it involves also a potential gain because the party that you like is more likely to come in office next period, and you may value that. You may value that for your period utilities next period, you're going to be using the policy functions of the party that aligns with your interests. Other than that, the equilibrium is going to be standard. The lenders are going to be internalizing all of these things and understanding what are the default rules and the borrowing choices of whoever is going to be in power next period. Okay, so moving to the quantitative analysis, we are going to measure tax progressivity in Argentina following exactly what Hitko and co-authors did for the US. We're going to try to match that average level of progressivity in Argentina. We're going to take the political affiliation by parties, meaning classifying which party was right-wing or left-wing from this data set compiled by the IDB. And we're going to take also some parameters from the literature that focuses on Argentina. So the calibrated parameters are going to be the standard ones at first here for the sovereign debt literature, the discount factor, the variance of these state shocks. So as you see, we're going to pick small variance of state shocks. These are mostly done to simplify computation. We're going to also have an issuance cost on debt to avoid the extreme dilution problem that was mentioned before and that was discussed a lot by Juan Carlos and Leonardo. And we're also going to have standard quadratic default costs. To match that, we're going to do exactly what the sovereign literature does: external debt, standard deviations of external debt, the spreads, and also the default frequency. What about the new stuff? The new stuff is going to be the political economy part. This is going to be the welfare weight that a right-wing party has for the right-wing households. It's going to be 75%. The welfare weight that for the right-wing households that the left-wing party has, it's going to be a little bit moved. It's going to be 0.20. And we're going to have also the household state shocks and the revolt costs. The revolt costs, we're going to model them on the baseline calibration to look like the default costs. So we're going to also introduce these convex revolt costs, and we're going to make them have exactly the same. I mean, in the calibration, they're going to end up having the same features as the revolt costs, as the default costs, meaning that lower periods of TFP are going to be associated with lower revolt costs. So revolts are going to be an inferior good in that sense. We're going to see that the specification of this is going to matter a lot for the results, and we're going to try to play around with other revolt costs. To get these parameters, we're going to try to match the share of income that goes to the right-wing households post-tax and pre-tax, the average level of tax progressivity, the frequency of revolts. This is where we use our data on the bubbles to try to say whether or not there was a period of revolt. And also the share of a right-wing government in power. This we're going to go all the way to the Menem presidency. That's why it's closer to 50-50. Because if you just focus on the last 20 years is mostly the left. Yeah, but we're closer to 50-50 if you go all the way to the 90s. So this is that's the calibration. This is the validation. This is not something that we targeted, but we can perform. We can do conducting the model a similar event analysis. Basically, we look at this probability of revolt as the political risk. We identify episodes in the simulation at the ergodic in which there is an increase in the probability of revolt, and we say, and we look at what's going on with the spreads around those periods of political instability, and we tend to find that these things are actually going hand in hand as well, even though we're a little bit overshooting the data on this calibration. We also have matched the regression results when we feed the data, and I could show you that if I could press the buttons, but you will just have to trust me for this one. You have a question, Nico? Okay, so what's going on? Let's try to understand, to unpackage the model and understand all of the how are these mechanisms interacting. So here you have a plot of at the ergodic distribution of the tax progressivities that right-wing parties and left-wing parties are going to impose on average. And we see that this is all exactly as we expected. Left-wing parties are going to be doing progressive taxes, and right-wing parties are going to be doing regressive taxes. This is exactly as we anticipated, but this is going to have an impact on the size of the pie. Basically, right-wing governments are going to have a bigger output because they're willing to do more regressive things, and that's going to allow them to have a bigger Y, basically a bigger output. Because they have a bigger output, they're going to be able to sustain a higher level of debt. So this is the distribution of debt at the ergodic by party, and you see that the right-wing parties are picking higher levels of debt. Remember that the parties have exactly the same betas and default costs. So the fact that they are choosing different levels of debt is mostly driven by what's going on with the progressivity. We also look at what happens with the defaults. So this is, again, is at the ergodic distribution. This is how much time the model spends under repayment, the 0, and this is how much time the model spends under default. This includes also the period of re-entering the market. So we get that parameter from Matti's work with Juan. We also look at what happens with the revolt decisions based on whether or not you are under repayment or in default. And I want you to get 2 takeaways from this. The first one is here in blue, is that at the ergodic, left-wing parties tend to default more frequently, tend to spend more time on default than right-wing governments. We're going to try to understand why. And also, revolts tend to happen more during defaults than under repayment. I'm going to try to understand why that's also the case. Okay, this is what I just said. Left-wing parties default more frequently. Interestingly, this would not be the case if we didn't have political turnovers. So this is what we get for the baseline specification that I just showed you. But imagine we also solve a version of the model in which there's a left-wing party that is always in power, and a version of the model in which the right-wing party is always in power, and we look at the default frequencies in the ergodics, and they will be the same. And this we know because the betas and the default costs are the same. But we're not getting that in our model. We're going to try to understand why. The second point is revolts are more common under defaults. In fact, revolts are allowing the economy to sustain more debt at lower spreads. And this statement comes from the fact that we compare our baseline model to a model with exogenous turnover. Suppose we shut down the ability of the government of revolts, so we only have the transitions that are driven by the exogenous shock. We find that in that economy, you can sustain lower debt, you face higher spreads, and you observe a bigger frequency of defaults. We're going to try to provide some intuition about why is that the case as well. And of course, in that economy, you would have exactly 50-50 chances of households being, right-wing parties being in power. Okay, so the first point, why does the left default more? So to provide intuition for this, we consider this very basic and simple 2-period model. You have linear consumption, there's no initial debt, that is 1 period, and this is the default decision in the next period. So this is the value the government gets if it decides to repay, and the only shock in the model, y is going to be kept constant, is going to be this default cost that's going to be drawn from a uniform distribution. So this parameter delta here is going to be the probability of default. and B star is going to be the optimal level of borrowing. As you can see in this setup, if you had two parties, one party called R and a party called L, that one of them gets YR, the high endowment in both periods, and one that gets YL both periods, they would both default at the same frequency. They would have exactly the same probability because they have the same beta and they face the same R. They would just make different borrowing choices, but they would both default at the same frequency. Now, so as in our model, if we had permanent types, the default frequencies would be the same. But suppose that you introduce a probability alpha that there is a political turnover. There is a probability that today a left-wing government is in power, but tomorrow a right-wing government will be in power, and vice versa. And the probability of the turnover is this parameter alpha. And I tell you this in advance at time 0. Well, what happens? So here, the dotted green lines is the z's for which you default. Above the z, you default, both parties default. So you can see with permanent types, the green lines are exactly aligned. But with a political turnover, we have different default sets. Different default sets that depend on whether or not the left stayed in power, so this is gray, left, left, and whether or not we have a turnover from the right to the left. So when we have a turnover from the right to the left, what happened? The right decided to borrow a little bit more than what could potentially be sustainable for the left. And when the left takes in, they decide that that debt is too high for them, and therefore they default. This is what Leonardo and Juan Carlos sometimes called a political default. The right decides to take that gamble when the probability of turnover is actually low. If the probability of turnover is actually high, then we have another type of political default that actually tends to happen when the left is in power and stays in power. If the left is in power and there is a high probability that the right is going to come in power next period, well, then the left decides to gamble and say, I'm going to borrow more, and you guys shouldn't worry too much because it's very likely that the right is going to be making the default decision next period, and those guys are going to repay. And when that doesn't happen, you have a bigger default set. So here you can see that even in a setup in which the preferences are the same, you can have these differential sizes in the default rules that are coming from the political turnover that wouldn't exist without that. So we go back to our model now and we simulate at the ergodic distribution what happens when we have a transition from a right-wing government to a left-wing government. And we look at in the sample how many, and we keep you in the sample as long as you haven't defaulted or you haven't been overtaken by the opposing party. And you can see that 20% of the left-wing transitions in the model begin with a default. And a very small fraction, less than 1% of transitions on the other direction do. So the model is generating these left to right transitions, and we think this is one of the ways in which revolts could potentially be increasing the likelihood of these transitions and therefore increasing sovereign risks. The other point, and I'm going to have to go briefly because I'm running out of time. We also see that in the model, we run again the same simulation exercise. We simulate a bunch of periods. This time we keep you in the sample as soon as you have defaulted. And then we try to see if you are able to re-enter in the sample, then if you are able to re-enter to credit markets, then we kick you out of the sample, or you have been overturned by the opposing party. So this is to convey the image that when there is a default, both of them are going to be facing a very high level of number of revolts, which is going to increase the likelihood that they get turned over. So the sizes of the color bar here is all of those parties that are not able to re-enter credit markets and are instead overturned by the opposing party after a few periods. So why do we have more revolts in default? We think at this stage that it may have to do that in the type of specification that we have of the revolt costs when you are already in default. So this is alpha when you have default and revolt. So what we're plugging in here in the revolt cost function is already the penalized TFP of you getting default. So when the government is, and because we know that this revolt penalties are lower when the TFP is low, a default is in a way making a revolt cheaper for the households, and that explains why you would get more revolts during defaults.
Quick question.
Yeah, go ahead.
Shouldn't all these things also imply that this government would like to play with the maturity structure of bonds differently? I'm wondering whether the fact that this is exogenous and you cannot play with it, lambda, whatever, this is the only margin of adjustment. But if we could play and understand that you come in later, I would choose a different lambda than you, and then maybe all these things go back to normal.
That's a very interesting question, and we think that yes, the maturity choice is one choice. Another thing is this: there's all of this literature on like feeding the beasts, basically because you know that I may be coming lower, I may be making different debt decisions to either constrain you or not constrain you. We think the revolts are definitely interacting with both of these features. We don't have a very good, I don't have a very good answer for you today, but we are going to go there. So we try also with different specifications of the revolt costs. So one of them is just, so we start with there are no revolts. This is the exogenous turnover. We try with a constant revolt cost that doesn't depend on anything, on A or anything like that. We still get a lower default frequency, but and we sustain more debt. So some of it is coming, so we do get some of our results, obviously not as much as in the baseline. We also try, this is our revolt cost independent of D, we also try putting A here as opposed to alpha 1, 0. That allows, that still keeps the level of defaults low, but it lowers the amount of debt you can sustain. We also shut down the ability to revolt either in repayment and in default. Basically, you allowing only for revolts and repayment, not only in default, and that has dramatic consequences. If you only allow for revolts in default, you can sustain a lot of debt. If you allow for revolts only in repayment, then it's the opposite. You can sustain very little debt, the spreads are super high, and there's a very high frequency of defaults. The baseline is somewhere in the middle, but it is coming from this fact that both revolts happen at periods of low TFP, but also the decision of default itself may be lowering the cost of a revolt. So to conclude, this is a quantitative model of how social conflict can impact sovereign risk and political turnover. The model is able to replicate this positive association between political and fiscal crisis that we observe in the data. We tend to see them together as well in the model. The model also generates that left-wing parties exhibit higher default rates than right-wing governments, and this is interesting because we don't make an assumption about them having different preferences for default or discount factors. We also find that revolts are more common during defaults. The relationship between revolts and sovereign risk is complicated. There are two opposing channels. On the one hand, revolts can increase the likelihood of political turnover and therefore increase the likelihood of a right-to-left transition. At the ergodic, I didn't have time to say this, but we have a 10% of right-wing governments that end when there are a lot of protests, and that left-wing and are followed by a left-wing government that immediately defaults on the debt. And this coincides a little bit with the story about what happened at the end of the Macri presidency. But we have this opposing force that by lowering the cost of revolts during defaults, revolts can act as a punishment to incumbents who decide to default, and therefore can allow the government to sustain higher levels of debt. And that's all I have. Thank you very much.
Thank you, Fernando.
So thank you for the opportunity to discuss this paper. My slides, should I? No slides? Let me start by saying that my opinions are my opinions and not the opinions of anyone else. It's in the slides. Okay, thank you. Okay, I can see them here, but you cannot see it there. But you can see it in the screen. Okay. So this is it was a very fun paper for me to read. I started thinking about politics, and that's how I came to think about defaults, and I've been thinking about defaults lately. So it was a good opportunity to come back to politics in a way. So this is a default model. We have already seen a couple of default models before.
What is new here, if you want, is that there are two types of consumers, low productivity and high productivity, that you can also think about left-wing and right-wing consumers. The government will choose the progressivity of taxation, and progressivity has a cost, a productivity cost. And then we're going to have two types of government. The left-wing government is going to give more weight to the utility of the left-wing consumers. Because of that, it's going to choose more progressive taxation. And what is the other novelty in the paper is that consumers can choose to revolt. And revolt has a productivity cost, but will increase the probability of government turnover. Okay. So the first prediction in the paper that you just saw is that the left is more likely to default. Okay, and this is in a way coming endogenously in the model. So I'm gonna have a lot of comments like this. The paper is very rich in predictions, and I would like to see like a deeper discussion of the data about these predictions. So is it true in the data that the left is more likely to default, and how predominant is that we have defaults by left-wing parties? Okay. So part of the reason why the left is more likely to default is because productivity and thus the cost of defaulting is lower with a left-wing government. And again, I will ask if this is true in the data. For example, the model, well, I'm not sure it was in the presentation, but in the papers, they say that under a right-wing government, debt to output is lower, but gross debt is higher. So is this true in the data or not? There is an alternative theory of what happened with growth in the data, and the idea will be that what a populist left-wing government will do will be to sacrifice future growth in favor of current growth. So then growth will be higher with the left-wing government, and then when the right-wing government comes, it has to implement austerity, and austerity is bad for growth, and then growth will be lower with the right-wing government. And with the cost of default, we usually assume this could be a problem. So I think most of this is in a paper by Scholl that Christina invited me to discuss 2 years ago. So that's how I remember. So the paper could be more clear about what is new in this part. Okay. Also, the model presented in the paper is a model of political identity. So you have left and right consumers, left-wing and right-wing consumers, and left-wing and right-wing governments. And the consumers always vote for the government, or they always prefer, well, I don't know because it's not very clear, but the idea is that it's assumed in the paper that they can only revolt against the other party. So the paper, I also would like to see more about the role of this assumption. So there are other ideas of how government turnover comes about. So the model is a model of political identity, but other people think that maybe political turnover is not about this identity voter, it's about the swing voters or the independent voters. And maybe the swing voters, they make decisions not based on the identity of the party, but based on the economic performance of the government. So we could kind of think about this question if we look at the data, and for example, we think about how correlated is the probability of political turnover with economic performance in the model and in the data, and whether we see differences in these correlations for the left-wing and right-wing governments. The paper also got me thinking about why and when are revolts important. So in the model, of course, revolts are very important. And what you have in the models is that the revolts will affect the spread. Is that true in the data? So when I look at all the revolts you just saw in the presentation, many of the revolts you see there, I think had no effects on the spread. So how often the revolts or the announcement of revolts, as someone asked, have effects on the spread and political turnover? Could be important for the calibration of the model. So maybe not all the revolts you have are the revolts you have in mind when you think about the effect of the spread. So maybe the best example of revolts that later, that happened before political turnover and a default is Argentina 2001. But again, if I think about that period, it's also true that there was a very poor economic performance and the government didn't have political power to implement the policies it wanted. So even in this case, I would wonder, Did we see political turnover because of the revolts, or did we see political turnover because of the very poor economic performance? So if we think that the revolts are mostly done by these identity voters, right? Revolts will not really change the probability of re-election, will not really change my view. So these are voters that already voted against the government. So when I see a revolt by these voters, I'm not thinking about political turnover necessarily. So this will also be something to discuss, okay? Then I thought that traditionally the way I was thinking about this, and people were thinking about this in the literature, we were looking at polls. So this is an example, an old example of the Lula, the first Lula election in Brazil, and as Lula was doing better in the polls, the spread were increasing. So we were thinking about polls, and the papers is kind of make me think, or I think it's proposing to kind of replace polls but by revolts. So are polls or revolts the variable I should be looking at? I'm not sure. In Argentina, we have very particular primaries. So these are primaries that are mandatories for all the parties at the same time. So it's like a super good poll, right? So this is what happened in 2019. On Friday, before this good poll, we have the spread at about 900 basis points. And then on Monday, after the poll, we have the spread at 1,600 basis points, right? So the realization that we were probably going to have a change in government from right wing to left wing, say, increase the spread by 600 basis points. So this is another example of how polls may be important and how polls may behave when they give you information about going from right to left. That is what they have also in the paper. At the same time, this is in the paper. This is a transition to Macri's government. So this is going from left to right, and the spread declined more or less 200 basis points from 600 to 400. Okay, so going from left to right, we see the opposite sign. Spreads are going down. In this case, a smaller effect, but I don't want to compare the size. But these are large swings in the spread with opposite signs. So my next question is, should we be looking at average effects? So the paper presents us the case of Argentina, but then also looks at average effects. And the message for the average effect is quite different. So this is the figure we just saw. So when we look at the average effect, it may be that this political instability or political uncertainty has no effect for most countries, but it's very important for some countries. So when we look at the average, we may be mixing both. So what you see in this figure is that the effect on the spread is very low, it's 20 basis points, so much lower than what we saw for Argentina. And it's more or less the same whether we have a left-wing government or a right-wing government. And we saw for Argentina, it seems to have had the opposite effect. So the paper claims some success by mimicking this behavior in the data. So we have this symmetric effect with the left-wing government and the right-wing government. But again, looking at Argentina, maybe we should have opposite signs here. And then they say, well, this is maybe too much because in the data we have 20 basis points and here we have 100 basis points. But again, if I look at Argentina, this may be too little, not too much. Okay. Another result is that revolts are more common against right-wing governments. Again, I would like to see more about the data. So perhaps the main contribution of the paper is about understanding revolts. So I was thinking how we can understand this better. So my recommendation will be to compute what the default and the borrowing policies will be for the consumers. So these are counterfactual, but what would they choose? And maybe they're choosing revolts. Revolts are like a way of voting. They're choosing to revolt. They're willing to pay the cost of revolting when they see that the gain from doing so will be large. So I'm seeing I'm running out of time, so I will go very quickly. There is also this idea that revolt increase the cost of defaulting, and this results in higher debt and lower spread. This is for the same calibration, so I don't know how much should we care about this because we can always recalibrate the model. Something I will probably emphasize, there is this discussion that governments default too late because the cost of defaulting is higher than the cost of defaulting of the consumers, and this prolonged crisis. So maybe your model can speak to that. I think there are some imprecisions in the discussion of Argentina. So the idea that Macri won with a platform of fiscal consolidation, I'm not so sure. I'm not so sure how you define austerity. So probably you could do something like looking at the structural fiscal balance. Using this index of political instability, so the index have the same value, I think, in 2016 at the beginning of Macri's government, when people thought he was very likely to be reelected, and also at the end, after he lost the primary. So I don't see much that this is reflecting political instability. Global factors in 2018. The idea that the 2020 government was promising austerity, they started by suspending the indexation of pensions. So I'm not sure this is true. And this makes me think about what is really the difference between left wing and right wing. I think I'm out of time, so I would like more description of political defaults in the data, some more details about the calibration. Then you have taxes in the title, but is tax the right instrument to think about difference between left and right? I'm not sure. And let me sum up because I'm out of time. I think it was a very nice paper. I have probably too many questions. Not all the questions are meant to be answered in this paper. Thank you.
Thank you. Fernando, quick reaction. Like some questions.
Thank you very much, Leo, for great comments. I don't think I can give you an answer to all of your questions, but I'll try to give an answer to some. So relative to when the left and the right are in power, it's not productivity that is different. They actually have the same productivity. It's output. They make a different decision about the amount of hours that they want both type of actors to play, and that's what increases the size of the pie. So you are right that we and on the model is very straightforward. We just have this tau1 parameter that is capturing the tax progressivity, but what we think is in the data, it's also capturing what were the different subsidy decisions that both the right and left-wing governments were making, and those were going in that direction. Macri was lifting the subsidies to electricity, and the left came into power saying we're going to restore those subsidies. On terms of the spikes about the average relative to the countries for which this matters a lot, I think you're absolutely right, and we should probably keep the focus on countries for which this is relevant, and this is definitely something we're going to do. It's a fair comment and well taken. In terms of the difference with what has been done in the literature, we think that given we are the first paper to give the households the ability to change the ability of have a political turnover. There are models of voting out there. There are models in which there are political turnovers, but usually the frequency of those turnovers is not something that it's on the hands of any of the players in the model. There's nothing like snap elections, and we think that's a big contribution that we're making relative to Scholl. But yeah, that's in terms to polling and election, it's perfectly well taken, and we can talk more about it bilaterally. Thank you.
Thank you. Any question? Okay, thank you very much. Let another round of applause for everybody. So that concludes our first day. We have, I think, dinner plans. I think it's 7:30, if that's correct. So maybe Carlos can tell us a little bit the instructions.
Thanks, Cristina. But the plan is to be at the lobby 7:10, and then we will take a bus to the restaurant. So at the end of the dinner, we will have a bus service waiting for us approximately 9:30 p.m. approximately. So we see you at the lobby.
And tomorrow we start at 9 a.m. So, thank you.